Test. Hey everybody, we're going to take about 5 more minutes just to get set up here on some AV things, so it's a good time to grab some coffee and some fruit back there, and then we'll go ahead and get started.
One. Yeah, I hear you. Okay. You think we're good?
We'll be good.
Test. You can go a little longer because we're going to start a little longer, right? We'll be 5 minutes off, 10 minutes off. Okay. Okay. All right. Okay, we're going to go ahead and get started. There's still a lot of folks that are out waiting to come in, but in the interest of time and trying to keep to a very busy schedule. I'm Josh Bottom, helped to organize this event. I'd say about 30 years ago, I showed up in Southern California with everything I owned in the back of the car and got my first job as a coder. And the folks in Southern California have always been very welcoming to me. And I can tell you, over the last couple of years, I've been going around talking to people about machine learning projects. And I go around the country, around the world to talk to folks. Some of the most interesting, most innovative type things are happening right here in the LA Basin. And the other piece that I would say is that the people are very open, right? When we first started this, I work on the Kubeflow community. We reported back to them that I was seeing a lot of interest in LA, and I said, hey, I would like to bring the community down to LA to do this so we could grow it and try to make things better. And so I talked to Konstantinos here, and he said, yeah, let's do it. And then we got to Taya. Everybody that is in the Kubeflow community today on the community calls, if you could stand up just so people can see who you are, that are participants in the community. So these are all folks that volunteer their time to build this project. I always think about why do people spend their extra times, right? And if you took how many people signed up for this, it was about 300 people, 350 people. If you think about what those salaries equal, that's like $50 million a year in talent that this room will represent when it's filled, once everybody gets through. The piece that I would tell you is, why do you do these things? If you look what happened at Cruise Automation, anybody familiar with Cruise Automation? Right? They were a company that was bought by GM. They were doing self-driving cars. They were bought about 2 years ago for $587 million. Last year, SoftBank and Honda put in another $2 billion into that company, which was held off. Right now, Cruise Automation is valued at $14 billion. When those investments by Honda and SoftBank went in to Cruise Automation, GM stock went up 2 points. I mean, this is not just impacting the software today is no longer doing a linear improvement of people's process. We're getting into an exponential space, and one of the leading places that I have seen that people are investing is in Kubeflow, right? So what I wanted to do today was then bring this all together and say, look, the heartbeat of Kubeflow to me have been these core contributors, and one of them is right here on the stage. So I would like you all to welcome Jeremy Louie from Google, who, nights, weekends, holidays, he's there to answer questions. And, I would just like to get a round of applause for Jeremy for everything that he's done over the last year. Jeremy, thanks so much.
Thank you.
And before I hand it off, all the speakers, what I'm asking them is, why do you do this? Why do you spend your extra time at Kubeflow?
Because I think there's a lot of really interesting applications going on outside in the world. So we'll talk about one of them, which is this natural language code search that one of our collaborators is working on. Ted, do you want to answer the same question? Why do you work on this? Why are you?
I think that.
I don't remember.
I work on Kubeflow because I think it's a great example of a really complex technical challenge that open source is well positioned to solve. So.
All right. So with that, let's get started. So by way of introduction, my name is Jeremy Levy, as Josh said. A very warm introduction. And so I'm the tech lead at Google for Kubeflow. Taya, do you want to introduce yourself?
Yeah. I'm Taya Lampkin, and I'm the open source strategist lead on Kubeflow.
So thank you all very much for coming today to hear about Kubeflow, and thank you, Josh, for putting this together. Oh, do you want to just log in again? Sorry. So we'll be talking today about Kubeflow and kicking things off, and we're going to be talking about building the next ML platform together. And so here's the agenda for today. We're going to start off by talking about why we built Kubeflow. So we're going to start talking about the problem that we're seeing in industry, which is that putting ML into production, into products, takes way too long, and we're trying to use Kubeflow and Kubernetes to solve this problem. And then we're going to describe in a little bit more detail what we mean by Kubeflow as a platform, and in particular, why we describe Kubeflow as a composable, portable, and scalable platform on Kubernetes. And then finally, Taya is going to talk about the community, what we're doing and what our community looks like. And then finally, we'll kick it off, close things out with a brief demo of what we have coming up in our next release, which will be 0.5 at the end of this month. And so what we hope you take away from today's talk and this day as a whole is that with Kubeflow, we're trying to make it easy to build machine learning products using Kubernetes. So let's start off by talking about why Kubeflow. So here's an example of a product that one of our collaborators, Hamel, who's a data scientist at GitHub, is trying to build, right? So what you're seeing is a search engine for code. So he typed into the search engine the query ping REST API server and return results. And then we're seeing him return some results, which are samples of code that are pulled from GitHub. And so the key thing here is that if you actually looked at those examples that he's returning, none of the words that appear in the search query appear in the code. So it's not like he's doing keyword searching and matching against the name of the function or the comments in the code. And the reason he's doing that is because he's actually used machine learning to learn what that code is doing and then learn how to map that to natural language so that he can search using natural language, right? And so this has a lot of amazing use cases for something like GitHub and outside GitHub, because now you can really use GitHub to search code, to find code examples that do what you need, and it has other applications like people who aren't, let's say, English speakers can search for language for code using their native language and find code that was perhaps written by somebody who doesn't speak their language. So this slide sort of captures the journey he went through, and it captures the sort of challenge we see throughout the industry. So he started off by building a prototype and exploring his idea in a notebook, right? And so a notebook, in case folks aren't familiar, is an interactive environment where data scientists use to sort of rapidly prototype and test ideas, right? And so with that, he spent about 2 weeks trying to build a model using some data from GitHub, and then sort of run some predictions inside the notebook to sort of do a reality and sanity check to see whether the results he was getting were useful and valuable. So after about 2 weeks, he saw that was successful. He saw that there was merits and that there's to this idea, and that he could actually build a machine learning model to solve this problem. So then he spent about 3 days sort of turning this into a pretty sort of web application, putting it behind like a pretty web server that you can sort of see here, bundling it up into like a Flask app. And he did that so he could, create a prototype that he could shop around GitHub and get people really excited and get them to sort of invest in it. But then the next step was actually sort of launching this publicly as an experiment on experiments.github.com. And that took 3 months, right? So most of his time and energy as a data scientist was not spent developing the model or trying to make the model better. It was actually getting the model into production and getting it launched, right? And this is what we see throughout the industry. And the reason we see this is because in reality, when you're building an ML product, what you end up with is a complex distributed system, and you end up with all of the DevOps challenges associated with managing and large complex systems, right? So this is a slide or diagram that's taken from a paper published by Google that was intended to describe why we spend so much time investing in machine learning related infrastructure, right? And so the key takeaway is that your machine learning code, right, so the algorithm, in terms of the energy and sort of effort spent, it actually ends up being only a small part of your investment. Most of your time and energy ends up going into the supporting infrastructure around it that actually turns this into a product. So managing your resources, like your VMs or your CPUs, doing logging and monitoring, security, all of that stuff. And so this is really the genesis of Kubeflow. We said, Kubernetes is really great at DevOps. It's really great at building complex distributed systems. Can we take advantage of Kubernetes and really create a platform for machine learning? So let's describe Kubeflow as a platform in a little bit more detail. So this is what the machine learning development workflow looks like, right? So as a data scientist or trying to sort of build a product, these are the kinds of steps you go through, right? So you start off by doing data analysis and data transformation. Where do I get my data from? How do I transform that data into data that I can inject into my model? How do I clean and validate that data? Then you go into the next step where you actually have to build a model, train it using your framework, whether that's TensorFlow or scikit-learns. And then once you have the model, you actually have to roll that out into production. And once you have a model, running in production and serving traffic, you have all of the DevOps challenges associated with, keeping that up and running and healthy. And so for each of these steps, we have different frameworks and different applications and tools and libraries that you might want to be using. Some of those are going to be developed by the Kubeflow community, and that's where we sort of indicated by the stars. Those are the steps where Kubeflow has seen some gaps, and we've decided to try to fill those gaps by building some applications and libraries. But there's also a large ecosystem already of tooling and that exists out in the community, and we want to make it super easy for people to use that in a cohesive platform. So this is what this slide is sort of aimed at giving you a sense of what the ML landscape sort of looks like. And it's a diagram that's being produced by the Deep Learning Foundation at the Deep Learning Foundation under the CNCF. And so what they've done is they've sort of divided the world up into these different areas. So you have like traditional machine learning, you have deep learning, then you have your models, you have natural language processing, you have notebooks. That second deep learning is actually supposed to be data management. I apologize. And then each of these boxes, you can blow them up, and you have a lot of different libraries and applications that you can use. So if we look at traditional machine learning, we have libraries like Spark MLlib that you can use. You can use libraries like scikit-learn. You can use XGBoost. Within deep learning, you can use TensorFlow or PyTorch or a whole bunch of other frameworks. And even then, once you've picked your framework, you have a bunch of high-level libraries like Keras and Gluon that you can use to really build your models, right? So the challenge we see is that as a data scientist and ML engineer, you have this incredible landscape that's very rich and full of tools, but actually cobbling these together into a cohesive platform is a really challenging and time-consuming problem, which is not where you want to be spending your time. And so with Kubeflow, we're trying to sort of organize the world and create a cohesive platform that's really easy for data scientists and ML engineers to consume. So this is how we've sort of diagram our architecture. And so this is one way to sort of view Kubeflow and get a sense of what it looks like. So at the lowest level, you can think of, we have a bunch of APIs and services that are very low level in the sense that they do one thing, and they try to do that one thing very well. And some of these services are going to be developed within Kubeflow by the Kubeflow community, but a lot of these are going to be outside the Kubeflow community that we're just going to sort of incorporate and integrate with. So as an example, we've created some Kubernetes custom resources to make it super easy to take advantage of Kubernetes to run deep learning frameworks in a distributed fashion, so you can scale out to train really large models on really large data sets by using multiple machines. But we're also leveraging services and applications in the broader landscape like Argo, which is an orchestration framework to do like directed acyclic graph type workflows. And we've been starting to work with Spark. There's a Spark resource for running Spark jobs on Kubernetes. And then if we go above this, we have some systems, as we'll call them, that combine some of these lower level services into more complete functionality, right? So as one example, we have a pipeline system which combines a bunch of different low level services to give users a full experience in terms of describing and running and managing complex ML workflows, right? So we use some of these low-level resources like Argo to run workflows, but then we provide a UI on top of that makes it easy to visualize your runs and the results, like the ROC curves for your models, as well as run those on a regular schedule, so that you can actually combine these services into complex workflows like I showed you before, where you don't just do, train a model, you pre-process your data, then you train your model, and then you roll it out into production. And then at the layer above this, we have a bunch of tools and libraries. So we have some command line tools like Arena, and we have some libraries like Faring that are really sort of focused on end users and really trying to create that usability layer that sort of hides some of the low-level details of Kubernetes and some of the other infrastructure, so that we have a really data scientist-friendly and usable platform. And then we have sort of what I will call these vertical areas, orchestration being one, where we try to tie all these layers together so that we provide a cohesive platform. So orchestration is one, because we want to provide data scientists want to do these complex ML workflows, so they have to tie together multiple services. And then metadata is the other one, because from all these complex, at every stage of these workflows, we want to keep track of what's happening so that we can understand what data we processed and how that was used to produce our models. And so here's sort of the takeaway. We want to produce a platform where the goal is users can consume their favorite ML applications and libraries, and we want to make that, so that's what we mean by composable, is they can use whatever library or framework they want to use. We want to be scalable, so we want to enable them to run either lots of jobs or take advantage of multiple machines, so scale out horizontally, but also vertically by using larger machines or using GPUs. And we want to be portable, so we want to be able to run in the cloud or on an on-prem data center, or even on their laptop. And for that, we're taking advantage of Kubernetes to provide a platform that runs anywhere. And so our hope, really, and one of the reasons that we're sort of trying to grow the community is we really think that as more apps sort of integrate with Kubeflow, that's going to attract more users to use Kubeflow because they can find what they're looking for on Kubeflow. And that, in turn, is going to convince more people to make their apps play well and integrate well with Kubeflow. So we're really trying to drive that virtuous cycle. And so with that, I'm going to hand it over to Taya to talk about our community.
Thanks, Jeremy. I'm going to start off by talking about some of the core principles that we've established in the Kubeflow community that help us organize not only how we structure ourselves socially, but also how we pursue some of our technical challenges. So the first of these three core principles is, for us, the most important. It's that we are an open and inclusive community. One of the things that Jeremy's touched on is that building an ML platform is a giant challenge, and we can't do that alone. We think that the Kubernetes community is a great model for how to successfully engage a large community to tackle like a huge technical hurdle. And we really want to architect our community in a way that empowers individual contributors to take ownership of the compatibility points that track with their expertise. What this means is that we consider all members of the community to be equal and have an equal opportunity to contribute their ideas and expertise. All ideas and perspectives are welcome. So what that means is that whenever we put a POC or a proposal out there, we really deeply want feedback. It's really important to us that we hear from a wide variety of both users and contributors to make sure that Kubeflow succeeds as a product. And we're also doing something internally right now within the community to define clear paths to community leadership. We think that it's really important to have a diverse set of very invested leaders from a variety of companies that are invested in Kubeflow to make sure it succeeds. And then inclusivity. We're committed to fostering a positive and harassment-free community. We support that by having a code of conduct, which we expect all of our community members to abide by, whether it be on GitHub or at events like these. We also have a really interesting inclusivity philosophy that we've put together in a document on our community repo that was authored by a collection of people, but championed by Michelle Kasban, who's one of our key evangelists at Google. Basically, it's an agreed upon set of rules that we as a community kind of abide by in terms of how we want to collaborate together. So it's more like what to do and less what not to do. We're actually hoping to roll that out as something that other communities can borrow from as well. And so just in closing for this slide, I think it's really important to have a diverse community of builders serving a very, very diverse community of users. We don't have just like one user profile. We have data engineers, software engineers, data scientists. We're trying to serve all those people, and that means that the people building this product can't be just one kind of person. I'm going to hand it back over to Jeremy to cover two other principles that help us organize how we think about Kubeflow as a technical project.
Yeah, so we have two principles that are a little bit more technical in nature, or the first, I guess, is a little bit more product in nature. The first is we really want to focus on having a low bar and high ceiling. So low bar means we really want to make it super easy to get started with Kubeflow. So minimize the number of Kubernetes concepts that people have to learn to get started. So if you go back to that original slide about what Hamel was doing as a data scientist, we want to make it super easy for somebody like Hamel, who's not a DevOps engineer, to get started, prototyping and developing his model, in a notebook on Kubeflow, without sort of having to get distracted by learning Kubernetes. But then once he has to get that model into production, and he has to start thinking about some of the more complex, DevOps things like scaling his model and security, we want that to be a smooth transition into doing those more complex tasks. We don't want him to fall off a cliff where now he's got to completely rewrite his model and choose a different set of tools in order to take that model into production. And then the final principle is that we want to be Kubernetes native. And one of the things that this means is that we're taking a hard dependency on Kubernetes, right? And one of the reasons we do that is as a community is that when we're designing how we're going to do things, whether individual applications or things like how we're going to support notebooks, we want to be able to focus on how we're going to do it on Kubernetes and not sort of have to think about and have discussions about what to do and how to support non-Kubernetes native platforms. And so this really helps us as at a technical level in that regard. And one of the reasons we can do this is because we think Kubernetes has been super successful, and it's now supported and runs almost anywhere. So we don't see this we see this as a huge advantage. And with that, I'm going to hand it back to Taya.
I'm going to dive a little bit deeper into our first principle, openness and inclusivity, and what that means in practice for our community. So we believe that open source is a powerful model for collaboration for a project like this that has so many different components, so many different communities that we need to be compatible with. And we really draw on the expertise of our community members to help provide that compatibility over a large surface area. We also want to provide a kind of test bed for machine learning innovation. Machine learning is still in the early stages as far as like the tooling that we need to support machine learning programs in production. And I think we really want to decentralize the innovation that happens in the project itself to make sure that people feel comfortable sharing their ideas, and that the different components in the project serve as kind of test cases for how to incorporate different technologies and see kind of which ideas prove out to be the best ones based on their usage within the community's components in the GitHub organization. So that's worked out well so far. We have a really giant community. Giant is a relative term, but I think it's growing very, very quickly. So as far as like our 0.4 release, we had 137 individual PR creators, which represented a 47% increase over the last release. We had 1,053 PRs for a 0.4, which is also a 43% increase over the previous release. We have 140 and counting community contributors that come from 25 and more companies. And you can just take a look at the logos on the right-hand side to see all of the people that are investing in the project today. And there are very many more that couldn't fit on this slide. Okay. So Jeremy mentioned how important it is to provide integrations with Kubeflow to demonstrate its use in the machine learning market today. We have some of our best demo creators in the audience right now. And we have a pretty good path for how to share your ideas as far as interesting integration projects and POCs in the community. So I just wanted to tell you how that works in practice. First, it's really great to connect with us in all the community channels we use. That's Slack for asynchronous communication, GitHub, which is our kind of gravity and source of truth for all technical conversations in the community, and then our mailing list, which is more how we socialize ideas and make sure people are aware of what's going on in the project. So after you get traction around your idea in one of those channels and come up with an interesting demo, you can provide it, you can demo it at our community meeting. We have once weekly community meetings that happen at alternating time zones to make sure that we serve all of our community members wherever they happen to be. And then we also encourage people who have gone through the effort of creating a demo to contribute it to our Medium blog. Medium blog is a little bit, in the process of being a better place for ecosystem projects to kind of be shared and heard there. But we really would like more contributors on the blog, so please let us know if you're interested in providing content. Okay, so a more kind of generic path to contribution for Kubeflow. If you are interested in getting more involved in the project, maybe you have an idea for an issue that you want to solve or just want to somehow get involved. First, we think that it's really important to start by participating in community meetings, participating in or reading mailing list discussions. That's the best way to kind of ground yourself in the technical milieu of the project. And then, of course, read our contributor guide. It's really important that you acquaint yourself with the processes that we use to get contributions through to make sure that your contribution doesn't fall through the cracks and that the investment that you put in it is well received. So a good place to start is a good first issue or help wanted issues that are tagged in the community, in the GitHub repos with that help wanted area tag. Then you'll open a GitHub issue, create a small proposal for more involved changes that you can use to build consensus with the community about your proposed design. And then once you've gotten that consensus, submit a PR and ask for feedback. Bring it to the maintainers, bring it to the community meetings until you get the feedback you need to get it into a release. Code is not the only thing that we need as far as contributions to the project. Other ways to help is evangelism and outreach. One good example is attending and speaking at events just like these. Documentation is really important for usability. We have a very fast-moving project that constantly changes, and we have a really high need for more people to collaborate with us on documentation. Issue triage is important as well, and we have about 444 issues open in the repo right now. It would be great to have more community members contributing to organizing those issues and setting priorities. Examples and tutorials that kind of define the happy path for our users who are testing out the product or serve as a reference for some of our more advanced users. Test and release infrastructure is a little bit of an unsung job, but is so important, and we're gonna figure out how in the community we can make sure that test and release contributors are the most important people, because I think they're the most important people. And then sharing your use cases, trying Kubeflow and giving feedback. This is an example of a use case that was contributed by a community member to our documentation website, but it's just actually one use case that is currently in the documentation or the use case folder on that website. We need more, and we're really, really looking forward to hearing how you're using Kubeflow today and how other people can use it for similar use cases. Finally, you can organize an event like this. So I want to give a strong thank you for Josh Bottom for putting all of this together. This came together at the last minute, and we need many more people bringing Kubeflow to their local communities across the US and the world. Okay, so I'm going to dive really quickly into what it means to do community development at Kubeflow before we look at that development in practice and take a look at our 0.5 demo for the upcoming release. So we release quarterly. This release process is managed by a set of community members that have come together in a product management working group. For each release and sometimes for multiple releases, we define a critical user journey, which is a key experience that we think it's important to develop to support our users in being more successful at their jobs. After we've agreed on a critical release journey to kind of organize our work, we take that to users, get their feedback, and then based on that feedback, we organize and prioritize our issues into release themes that then community members step up to coordinate and throughout the life cycle of the release. We also report on the release progress weekly in our community meetings and also our product management meetings. Another really key theme that's kind of blossoming in our community right now is user-driven development. We just released our first ever Kubeflow user survey and got a really great response from the community. It was run and created entirely by the community, a joint effort from Josh Bottom, Elvira from Cisco, me, and with some advice from our UXR researcher at Google. We wanted to dig into who, why, where, and how people are using Kubeflow today. We had got 81 responses, which is actually a really, really big response for a small survey like this. And we hope that this is a first step towards building a Kubeflow User Advisory Council that will eventually give us programmatic feedback on our CUJs and help us set our roadmap and release milestones. Just a couple interesting slides I wanted to share based on results from that survey. is an example of how we break down the users as far as what their primary roles are within their organization. Clearly, data and machine learning engineers are the biggest users of Kubeflow right now. We hope to eventually expand the number of data scientists using Kubeflow as well. Mostly enterprise users are investigating Kubeflow, which was a little bit affirming for us. We think that Kubeflow is most useful in the enterprise setting, so that was good to see. And then finally, this is a look at what people are looking to improve with their use of Kubeflow as far as their existing machine learning processes and programs. And so I think that this kind of project is going to help us make sure that we're steering Kubeflow in the right direction. I think it's really important because many of the people working on Kubeflow are not necessarily the target user. And so having this program where we programmatically get user feedback is critical to driving our release milestones. We're going to have a demo of our 0.5 release that Jeremy will show you guys.
This is a quick preview of our demo. Let's just go ahead and play that. So the idea here is that we've deployed Kubeflow, and so we're just get started. We're just showing you through the dashboard in GCP all the different services that ended up getting deployed as part of your Kubeflow deployment. And we're just kind of trying to illustrate the overall breadth of the platform. But the key thing starts right now, where you can see what I'm doing is I'm creating a namespace, because what we want to, one of the things we're sort of focused on is enabling teams to sort of operate in an environment where everybody gets their own isolated environment in which to run things. And so after I've created the namespace, you can see this is our central dashboard, which allows you to sort of navigate between all the different services. And from here, we've clicked on the Jupyter Hub page to actually spawn a notebook. And you can see we have this form-based approach where you can easily spawn different notebooks, and you can specify the resources and the Docker image that you want to use, as well as a name, right? So from here, you can spawn multiple notebooks. And then you just click spawn, and now we're going to wait a second for it to spin up. And it takes a little bit of time just because you have to pull down the Docker image and get that started. And so while we're just waiting a second for that to start, we'd love to have you. One of our calls to action today is we'd love to have people try and share Kubeflow. So try out Kubeflow. Go to our webpage and then get started with it, and then share your experience with us on either Slack, GitHub, or one of our or the mailing list. And then the final piece that's showing up in the demo is that you can see we're actually spinning up a notebook. We're cloning an example from our repository, and in this notebook, we're actually defining our model. It'll come up in a second. And then one of the things we've added to our notebook is we've added a library called Fairing, which is going to be in our 0.5 release. And this allows you from your notebook to automatically turn your notebook into a Docker container and then spawn that up on Kubernetes, either for running the training or for doing the deployment of the model. And so we're completely hiding Kubernetes from the data scientist in an effort to make it more accessible. And so with that, no, it's not. Okay.
Yeah, so what we'd ask of you as you depart from SCaLE later today is to try Kubeflow, give us feedback. If you just really run into some major blocker, we'd love to hear about that. And then finally, we are looking for local meetup organizers or event organizers or speakers who are interested in starting up a community here in LA. If that's something you're interested in, please come and talk to me at lunch, or just email me at tedlampkin@google.com, and I'd love to work with you. Thanks. Do you guys have any questions? Yes. Oh.
Yeah. I mean, in your slide 10, you mentioned the MPI CR. Is that message passing interface? Okay, thanks. Okay, thank you.
Any other questions?
Big fan of this project. Is there any future roadmap to incorporate more classical machine learning frameworks like scikit-learn?
Yeah,
right now it seems very deep learning centric.
Yeah, so we're making a big push to better support Python frameworks that are already supported in Kubeflow. We just haven't done a really great job promoting that. But like with Fairing and some of these other efforts, one of the things we're promoting is our XGBoost support and some more traditional machine learning support.
Any other questions? Great, thank you.
Is GPU resource management addressed by Kubeflow at all? Is that kind of just offloaded to your own Kubernetes setup?
Yeah, mostly we rely on Kubernetes to handle resource management, including GPUs, and mostly we just provide sugar on top of that. So as an example, like in our Jupyter Notebook spawner, we've made it super easy to attach GPUs to your notebooks, but under the hood it's using Kubernetes. We're just kind of surfacing it in a data scientist friendly way.
Any other questions? Awesome, thank you. I'll give it back to Josh, I think. Where'd he go? Oh.
So while Timo's getting set up, just by show of hands, it was interesting in the survey, we saw more machine learning platform engineers using Kubeflow than data scientists, which was kind of reversed from what we thought. Just show of hands, are any machine learning platform engineers in the room? Kubernetes-based folks? Yeah, okay, great. What about data scientists? Great, so we got some of both. Good. So, Timo, you're getting ready here? I'm surprised we don't have more questions. Now, come on, there's got to be a couple stumpers for Jeremy, who's done such a good job on this. Is this kind of what you guys were expecting to see from the platform? Was that a good introduction? I mean, come on. Well, so give me an idea. Why did you show up? I'm going to ask.
It just seemed like an interesting track to be on for day one. I wanted to learn more about Kubernetes, and I'm interested in getting more into ML as well. So I'm a bit of a novice, you could say. But yeah, seemed like a good place to meet like-minded people too.
And that's really it. I mean, if you can make a chance to meet 4 or 5 people, I think what we saw in Dallas when we did this is that people started working in little teams together and helping them solve problems, and it was a nice kind of flow on how things kind of grew. And in fact, talking about Dallas, Timo, how are we doing? He can do machine learning but can't plug his laptop in. No, I'm just kidding. Yeah, I'm just kidding you. All right. You want to use the...
I think we'll go ahead and actually get started. My colleague is just grabbing some water back here. But I'm Timo Meckler, and this is Charles Adetoloy, who's just walking up to the stage. We're both from Maven Code, and we're going to talk to you guys today about orchestrating and deploying machine learning platforms at scale with Kubeflow. But before we really get into the meat of our presentation, we're going to talk just a few minutes about our company and ourselves. So Charles and I both work for Maven Code. We're a Dallas-Fort Worth-based software and consulting company. We started in about 2008 and have worked with a variety of clients both large and small companies in the data space since that point. Today, our primary areas of expertise are in providing our clients both deployment and the deploying of scalable AI and ML pipelines and building out that related infrastructure. We also work with our clients to do the actual modeling once we've deployed data pipelines. We more broadly offer cloud services to our clients, so we still work with clients today to help bring legacy applications into the cloud. We build applications, microservices. We provide consulting around Kubernetes, deploying that, managing that, and more recently, actually with Kubeflow, and I guess that's why we're here today. We also have a data security practice in our company. We're a data company, and we take data security very seriously. So this is one thing that we offer. And then finally, we also offer training to both small teams and enterprises on these topics, whoever might be interested. About ourselves, so again, my name is Timo, and I'm an architect and product manager at Maven Code. I've been with the company about 1.5 years. Prior to joining Maven Code, I spent a good 7 to 8 years working in energy commodities trading, both as an analyst and a strategist, working on trading desks, building out scalable research platforms and developing trade strategies, working a lot with traders. And then Charles, next to me here, has got well over a decade of experience working with many different companies and building large-scale distributed data software platforms, and again, across a variety of different verticals. So he's got a lot of experience there. But that's enough about us. We always like to start kind of with a motivating question, and that is, we're all here because we have some interest in AI and ML, but really, why is the time right now to do machine learning? And for us, it really has come down to three main things. Number one, it's just the availability of data and the amount of data that's being generated. Everything these days seems to generate data. We're able to store that data. In fact, I think we'd all be surprised just how much data is being generated just in this room on our devices right now. But it's not just data itself. It's also the ability to process that data, having these computing resources, and having services on managed cloud providers such as Google, Microsoft, AWS. The ability to be able to spin up, say, 1,000 virtual machines in just a few clicks of a button, to be able to really process large scale data. And the third thing that's been really important is the ability to model. All these modeling frameworks that have come about in the last few years and continue to grow and mature. So it's really the combination of these three things, that in our opinion, that's really gotten us to why the time is right now to do machine learning and to do machine learning at scale. So if we got everything there, then okay, things should be pretty straightforward, right? Anybody can just get started on machine learning. So we found through our practice that there's still a lot of perception that machine learning is kind of simple like this. You start with some data, maybe it's pretty pictures of puppies, maybe it's a time series, then you sit down for a while, and hack away at your laptop or desktop and just write a lot of really cool machine learning code, and out comes the result, the predictive power of the model. Well, while you can do things that way, the reality of the matter is that things aren't really quite that simple. And just like the presentation before us, we also saw that writing the actual code is just a really small component of a machine learning pipeline. There's a ton of data collection that needs to go on to really be able to get a good model performance and be able to do machine learning at scale. You have data, but is it good data? You have to verify data. You might have to label it. You might have to transform it, and you have to store it. And then you have to set up all the infrastructure for that data ingestion to do that. Once you actually have your data and you start modeling, it becomes about actually describing the data properly. Do I have the right features? Do I have to do feature engineering? And once you've done all this, there's more yet. Let's say you have a model you like, and okay, now I'm ready to put this thing into production. Well, you're not done yet. There's serving infrastructure to worry about. Once you get it into production, you have to monitor it. Is the model performing well? Is there bias being developed? Do I have to retrain? And then there's the management of just all these resources, all these machines, et cetera, that you have to worry about. And finally, analysis tools. So really, an actual machine learning pipeline, is far more complex than just sitting down one afternoon and writing code. And we at Maven Code, through our consulting engagements over the last decades, and particularly over the last few, also realized this, And so what we've done actually internally is build our own software platform to make this simpler. And that software platform is called Smart Deploy AI. And I'm just going to give a quick plug to this before we get back to Kubeflow. But essentially what Smart Deploy AI does is take away this side of the diagram and help automate it. So we've built a platform that helps anyone really quickly bring up scalable AI and ML data pipelines in the cloud or on-premise. So really we have an automated platform that allows you to do that. And this is great if you're in a situation where, again, you may not have the DevOps expertise, but you really want to do AI and ML at scale. With Smart Deploy, we can cut the time down to get you running up at scale and the cost down. So we think this is going to be just a wonderful tool as AI and ML get more democratized and small organizations and mid-sized organizations are looking to really get ramped up on this. Instead of spending a lot of money and hiring a lot of DevOps engineers and multiple data scientists and developers, with Smart Deploy AI, a couple data scientists can get up to speed very quickly. So, drive that home. Our Smart Deploy AI platform really makes it seamless to set up scalable end-to-end AI and ML platforms in the cloud or on-premise. We are already using this internally with our client engagements, and we're looking for a broader release to the public later this spring. And one quick last plug about the platform and its features. When we do integrate it with Kubeflow, and one nice thing that we also offer is intelligent monitoring of that whole data pipeline. And we offer people that are involved in the whole AI and ML process in the organization to be able to collaborate. So there's a collaboration workflow. We offer metrics so that anyone from the data scientist all the way up to the C-suite can see what's going on. Are we seeing the right return on this project? How much are we spending? Should we continue to pursue this, et cetera? So that is really a big part of the platform we're very, very excited about. And we actually got certified or got accepted into the Google Cloud SaaS initiative just this past month. So very, very excited about that. But enough about our product. Let's go back and talk real briefly about what does a typical machine learning production deployment lifecycle look like for us at Maven Code. So we've worked with a variety of different clients and a variety of different industries, energy, oil, gas, telecom, retail. It always starts out with having some domain knowledge. You need to understand the industry that you're in. If you're trying to model something you don't understand, it might not turn out so well. So we start with that, and it's all about the data, making sure you have the right data. Do you still have to acquire data? Do you have to label, transform, store that data to make sure that it's actually ready for modeling? And once you've got your data, then we work with the client and say, okay, what's the right kind of model to use? What should we be doing to model this? And then you start modeling. Once you've got a model, you start training. You start figuring out, am I getting the right performance? You start testing, validating. You might go back and say, oh, I don't have enough data. I need to start over, collect more data, then try this again. You tune the model some more. And then after a while of this iterative process, then you say, okay, I've got something that I'm ready to put into production. And once you're at that point, we've always encouraged our clients to deploy on Kubernetes because we've worked a lot with deploying cloud-native applications on the cloud. And so Kubernetes provides this common layer for deployment. So the whole point really about this is when you have this production lifecycle, you want to be able to repeat that over and over and over again without having to spend a lot of time and a lot of money to redo it. For example, if you're a company and let's say you have multiple power plants and you're trying to model each plant separately, you should be able to use the same life cycle, the same process for each one without having to spend 6 or 9 months to get it going. So you're really looking for having a common deployment platform. And it's also important for organizations, if you're the data scientist in the organization, as we already learned in the last presentation, you do not want to focus on the deployment details. You want to focus on the modeling, the domain knowledge, describing the data properly, collecting the data. But by being able for us to deploy things on Kubernetes, we are able to do things like model serving, scoring, performance evaluation, monitoring, versioning, and so forth. So really, we want to use Kubernetes, that's become so popular for deploying cloud-native applications to build a cloud-native machine learning stack. That's what we're trying to do. And so the idea is that it doesn't matter what infrastructure you're on, whether you're on Google, Microsoft, Amazon, or you're maybe on-premise, Kubernetes provides that common layer. And then by putting Kubeflow on top, we're able to do machine learning deployment easily, and the data scientists can interface through that infrastructure, through a Jupyter notebook, and really just has to worry about what modeling framework and process do I want to follow? Do I want to do training in serving TensorFlow, MXNet, PyTorch, or even something else? So with that, I'm going to pass it over to my colleague who's going to talk a little bit more in detail about kubeflow pipelines and how we deploy them.
Thank you, Timo. Yeah, so one of the things we do and the project we work on is to help our clients through the life cycle of getting data all the way to where we can model it and do some analysis for them. So a typical use case could be like this. We have clients generating data from sensors on maybe windmill farms, or maybe from the oil rig or from Texas, or maybe an healthcare IoT device. So we do all our, in this case, we're running in the cloud, so we run all our analytics on Google Cloud. So our typical framework looks like this. So one of the things we've done is to leverage on the kubeflow pipeline, which is one of the great projects under the kubeflow community is working on. We want to be able to compose this infrastructure and basically be able to deploy it and make it very repeatable. So in this case, we're trying to deploy a model and train a model and push it out to edge device. A lot of all these devices can run TensorFlow model with TensorFlow lights. So what we do is we ingest the streaming data coming into a PubSub queue. It could be Kafka, it could be anything else. We use Dataflow, or if you're running on, you can use Dataproc as well, or use run a Spark ETL process to do that. Then we write it out to a storage location. So we want to be able to compose all these steps with kubeflow. And one of the things over the years that we've evolved to, one of the things we're doing right now is to run our pipelines with kubeflow pipeline. We can compose all these tasks into small subsets of tasks. And we have a task stage for reading the PubSub queue, and another task stage for bootstrapping the ETL with Dataflow, then another task stage to write it to a storage location where we can use it to train our models. So what's the kubeflow pipeline like? So the kubeflow pipeline basically allows you to bootstrap your infrastructure and run your runtime code. So everything is all Docker container. So you start up that Docker container. It kicks off, it bootstraps your infrastructure. So let's say you're connecting to a queue. It's gonna launch the connection. You need to connect to that queue. Then it will execute your runtime code. So a typical setup will look like this. We have our runtime, the components instantiation code that bootstrap the infrastructure. Then inside that, the Docker container fires the runtime code that connects to the queue and read up all the things that we have in there. So this is a snapshot for our project setup. So the Docker file basically wraps up everything and you deploy, and that's a unit of work, and that's one of the tasks we execute. So the whole idea is for us to concatenate all these tasks and create a DAG, which is what becomes the kubeflow pipeline. So looking back at the pipeline we have on the previous slide, it's going to look like this. We have the first step will be to connect to the queue, read up whatever message we have on the queue. We do an ETL process, probably to clean up the data set. What's that? Hello? Oh yeah, sorry about that. So the first step will be for us to connect to the queue, read up the message from the queue. Then the next step will be for us to do an ETL process. Maybe you want to clean up the data, reorganize the data, and things like that. Then the next step will be for us to roll it up and write it to a location where we can feed up the data sets for our machine learning training. So overall, the pipeline looks like this. We bootstrap our pipeline. The pipeline contains all these stages: the data flow ETL stage, the roll-up stage, the training of the model stage, and there's the kubeflow pipeline has an annotation for you to compose all these steps, and this annotation helps you to compile and generate an executable generative compressed file, which is an ArgoML. It's a big contribution from the ArgoML team, and we can now deploy these and use it to run our models. So once we do that, the generated zip file that contains the pipeline information and all the metadata about the pipeline, we upload it to our kubeflow pipeline. So from there, you can see the DAG, all the stages. So you can I mean, one of the cool things about this is like you can debug each step of the pipeline. So let's say I'm ingesting data and something is not coming on properly, I can go in and debug that stage. Maybe I need to upgrade my ETL process. Or I need to like concatenate my ETL process with some other process as well. I can do that. So this is a simple like 4-stage process as part of our pipeline that we go through. We can run multiple of these in parallel, but once you upload the pipeline information, you get this nice diagram that illustrates your DAG and everything going on in your pipeline. So the cool thing about this is like Jeremy and Timo alluded to earlier, is like whenever you're building a machine learning pipeline, you want to be able to manage the process and not get like entangled with all these other things. One of the things, the advantage of building our pipeline this way in the past few months is like we want to try out different things. The customer comes in as like, hey, we have this new data source, we have this new event attribute coming as part of the event source. We want to be able to like append it to what we're doing. So in the past, doing this was really a pain. So, but now we can create a different version of the container code running as one of the task unit, and we can quickly test it out. So if everything works out good, then we can flip up that version, which is all these things are just Docker images that you concatenate along your pipeline. So I can decide to like create a new version, test it out real quick for my maybe reading of the events. If everything is okay, then I can just promote it and decommission the old part of the pipeline. And this applies to any other part of the pipeline. I may just decide to like do some more test. I mean, my training of my model, I might want to do some more training, create a new version of the pipeline that, I mean, of the task on that stage that does the training and deploy it as a Docker container. And once everything works out good, then I can flip it over. So the other thing, the advantages of doing this as well is like I can run multiple experiments. So normally whenever you're doing machine learning, you want to like test things out. You want to change your hyperparameters and see how things behave. So with this, we can run multiple experiments concurrently by changing all the hyperparameters, running it through the pipeline and seeing how, I mean, checking out everything behaves. So with that, I can have different versions of my model, do quick A/B testing to see how things are going. So to that, the advantages of Kubeflow pipeline for us is mainly allowing us to like scale and doing distributed training. It's a lot more easier than before when we first got started, where we have to bootstrap all these things by writing shell script to do all our DevOps and stitch things together. We can do faster. The iteration is a lot more faster right now. So we can easily like train multiple models at once, see the results and see how everything is behaving. Overall, our productivity has increased as a result of this. Then serving the model, the other part I didn't show in this diagram is the serving part. So with this, we can serve our model and see how the model is behaving, I mean, in production, and see we can do quick A/B testing to see which model is better, and based on that, we can decide to adopt a model or promote or decommission a particular model. And the other cool thing is like because all these things are Dockerized and they're containers, and each stage is part of the pipeline. There's a lot of all these Docker containers out there that we leverage on. A lot of them are pre-installed with things like TFMA, TensorFlow model analysis, where you can do real-time analysis of what's going on your model and see how the two models are behaving. TensorFlow transformation framework, which is part of Apache Beam. We use that a lot for all our data flow ETL process. So we can leverage on all these pre-built models, Docker containers that contains all the things that we want to do. And we can control when we decide to like adopt a particular release or change, because all these things are in a big flux. So one of the things we notice is like if you're using Apache Beam and there's a slight bump up in a version of it, and we're not aware of that, it can derail a lot of things that we're doing. So we want to be able to like control our own internal environments whenever we're building all these things. So with this, we have a lot more control in terms of how we deploy things and how we accept things from the community into our own internal development ecosystem. And overall, it makes things a lot more portable, because Kubernetes is a common baseline for all these infrastructures. We're a consulting company, so we want to be able to like build things that we can repeat across for multiple customers. So if you're running on Amazon, on Google, or Azure, or on-prem, as long as you're running Kubernetes as a baseline, I think we can easily help you get things going on your team. And overall, for us, is the efficiency and from our team in terms of like getting things out and getting things going for everybody. So I'm going to hand it over back to Timo. If you have any questions, we'll be able to answer you as well.
Yeah, just a quick thank you to everybody, Google in particular, for giving us a bunch of credits to burn on Google Cloud to get all this up and working. Conference organizers here, and especially to Josh for putting all the effort in, and the Kubeflow team for working with us. And then finally, just a little bit about us and how to get in contact with us. Again, we're a consulting company. If you're looking to get spun up and build a data pipeline in the cloud, or you're interested in learning more about our Smart Deploy AI platform, come talk to us afterwards. We'd be happy to discuss that. So with that, I'll open up for any questions in the audience. Yes, actually.
Yeah, after looking at some of the slides on Kubeflow and US, does it work like the Amazon AWS SageMaker?
The question was like, does this work like the Amazon AWS SageMaker? To some extent, yes. But the thing about SageMaker is like you're locked into Amazon. So, and if you're trying to be cloud native, if you don't want to be locked down to a particular vendor, because the GPU prices varies, it's a lot more cheaper with Google to like run all these kind of workloads. And the other thing is like you can run this as a managed service. So what I mean by that is like on Google, you have things like Dataflow that you don't have to worry about your ETL process, bootstrapping the server and everything like that, or BigQuery and all those kind of services. With that, you're not logged in. You can decide to like move back to Amazon and do things on Amazon as well. But the whole idea is for you not to be logged into a particular infrastructure provider in this case.
Do your customers tend to reuse the same infrastructure for the training portion and for the serving portion, or do they tend to have separate, whether it's separate physical infrastructure or separate clusters for those two purposes?
Yeah. So to that question, in most cases, yes, because they're running entirely on Kubernetes, so you can have a serving on a particular pod running in your Kubernetes. And you can have it training the model on the infrastructure as well. And if you're using managed services on Google, you can use things like Cloud ML. In that case, it runs on a different infrastructure. And for like, if you're building like IoT devices, all these edge devices, you can actually push your model to that device after training them. Any more questions? Questions? I think that's it. Yeah, thanks a lot for having us.
Can you hear? Oh, you can hear me. Okay. So, yes, I think we are. So, hello. Thank you all for being here. My name is Vangelis Koukis. I'm the CTO of Aricto. I'm here to talk to you about advanced data management with Kubeflow. Okay. So, Josh asked, very first thing he did, right? What's our motivation in this? Why are we working with Kubeflow? Well, exactly as Jeremy mentioned in the first presentation, where will machine learning run on? Machine learning will run on Kubernetes. Kubernetes is becoming the de facto standard for deploying applications across clouds, on-prem, in the cloud, the single declarative language of explaining what kind of workloads you want to run. Okay. And then you're interested in ML workflows, right? Okay. What do you need to run ML workflows? You need all these things. You don't just need a model, you need your data sets and your notebooks. That's where you work with. Okay, how many of you use notebooks? Lots, I guess. Can I have a show of hands? How many of you use notebooks? Lots of people use notebooks. Okay, and then you need to run training and maybe distributed training in parallel, and then you need pipelines, a single declarative way, reproducibly, to explain what you want to run in sequence, okay? And then you need to track your experiments and do hyperparameter tuning and serve and deploy in production, and you need to monitor this. Okay, are you going to build this yourselves? You'll use Kubeflow for this. That's what Kubeflow does. Kubeflow containerizes all these things on Kubernetes exclusively, so you can go on with doing the actual hard ML work instead of having to worry about how do I run my models on Kubernetes. Okay, so having seen this and having seen people struggle with how to get the workflows, and Kubeflow is a composable, reproducible way of doing this, what do you need next? So you need all of these components. This is a full ML workflow, okay? And Kubeflow's mission is to make super easy for everyone to develop this kind of workflow and deploy it anywhere and manage it across platforms, across locations. Okay. So if I have these components, I'm done, right? I'm good to go. Well, no, you're not. There's something missing. Kubeflow gives you a reproducible, composable way of declaring what you want to run. Are you okay? There's this tiny bit missing, which is you need your data to run. You need to track your data. You need to know what data you worked on to produce the results you produced. Oh, I have this great model, it works, it's got 99.99% accuracy. Okay, can my colleague reproduce my results when they train? No, why? Because I used this specific data set which no longer exists. Or because someone cleaned the data set, but the way they cleaned it, which was supposed to improve accuracy, well, it actually hurt accuracy. You must have seen this, right? How can I go back and have full lineage for my model? I need to have a reproducible way of explaining how this model came to be. I need to track my metadata and my data. So what do people do today? That's what we can talk about. And why are we in Kubeflow? To show an end-to-end data plus code way of working and make this work for everybody. So this is a figure from the TFX paper by Google. TFX is Google's internal ML platform, right? And all of these components have been open sourced now by Google. These are libraries to do specific steps in an ML pipeline. Okay, so Kubeflow, the paper assumes there's a shared configuration framework and job orchestration framework. In the case of Kubeflow, this orchestration framework is Kubernetes. Kubernetes will orchestrate your workflows as pods, right? And then Kubeflow covers this. It containerizes all of these and more components to give you a very easy declarative way of saying, I want to run a parallel job, okay? And then Kubeflow takes care of this. an integrated front end for essentially logging into the cluster and using it. And our contribution to Kubeflow is we're major contributors to the notebooks and UI front ends for Kubeflow. We start from the user. How can the user actually log in and use the infrastructure? They start from notebooks, so we are contributing to this. So this is the one end of the story. And then the other end is these two layers at the bottom, shared utilities for garbage collection, data access controls, and pipeline storage in general. What is this going to be for Kubeflow deployments? This is where our software comes in. So we give you software to manage your data as your pipeline runs. We are the mount point that you see. We are the file system you store stuff in. And you can then snapshot this file system and reproduce it and clone it and share it with your colleagues so you can have a reproducible full workflow. So why are we in Kubeflow? To tell an end-to-end user-driven story. One end is how do people log into the platform and explain what they want to do, and the other end is what happens with their data at the lowest level. Traditionally, we have been data management, storage people, but Kubeflow has been such a vibrant, user-driven community, so that's why we are part of this. So we'll talk about data in this presentation. And please feel free to think about how you use your data and ask questions accordingly after the presentation. So our mission is planet scale data management. Manage your data across platforms, across locations, globally. We give you software to snapshot all of your file system, version it with a specific version, package it, distribute it in a peer-to-peer way with your colleagues across locations, share it from a single pane of glass so you can have access control lists, who sees what. And you can do it across teams and locations, on-prem, on your own deployments, or on the cloud. So how does this fit into the Kubeflow pipeline story that Maven Code also very nicely explained in the previous presentation? You have a pipeline. It has 3 steps. How do people actually make the steps work today? What they usually do is they have all of their data in an external data lake, and they write specific code to access the data lake. So I know my data is on S3, so I import S3 client, I import my tokens, and I go to S3 in these specific buckets and find my data. That's what you do. Okay, what happens if this data changes? I don't know. What data did my pipeline use when it ran? I don't know. Can I run my pipeline on Google Cloud and keep my data on S3? I can, but then performance suffers. Can I develop on-prem and then run my pipeline on the cloud? Where's my data? So the traditional approach is import S3 client, go to the lake, bring data locally, because that's the only way to actually have bearable performance. Crunch it, then store it back to the data lake. Lather, rinse, repeat for all steps. That was a right click, sorry. Okay. Is there any better way? Yes. So we are your data management layer. You mount us, you work on a disk that you see, /data, data 1, data 2. You can clone this disk from an existing snapshot, so you can have ready-made versions of your data to start from. I want to start from this data set. I declare it, I access it via /data, and I see 1 terabyte of data. This is a local disk on your local cluster, no matter where you are. And then when the step runs, what do you do with this data? Do you allow the next step to just go touch it? Well, you can, and that's what you'll do. You don't need to transfer the data, it's just there. But before you allow the next step to mess with the data, what do? You snapshot it. Why? So you can go back in time and see exactly what the step produced. So you have a declarative, reproducible, immutable pipeline. Everything is immutable. You can go back in time and see exactly what happened. So the next step starts from a clone of whatever the previous step produced, and then the next step starts from a clone of whatever the previous step produced. This is our vision for advanced data management in Kubeflow. And then by having every Kubeflow component work with persistent volumes, you can use this across Kubeflow. So our mission is to make sure every single Kubeflow component uses Kubernetes persistent volumes in a vendor-agnostic way. And then we know that our technology integrates as one more storage vendor in Kubernetes, and you can do all these things. This is the end-to-end story. Make sense? So why is this important? Because underneath, we use a local object store to store everything, but the users never see this. So we maintain hashed chunks of your data on a local object store. If you're not working on Amazon, we use S3. If you're working on-prem, we can use a standard NFS share. So then, because you have a way of running your pipeline, what if you want to run a pipeline in a hybrid way, both on-prem and on the cloud? Because every step gets its input as a snapshot of the previous step, running a pipeline in two locations becomes running a pipeline, a meta pipeline of two steps. Step one, run a pipeline on-prem. Step two, run a pipeline in the cloud. How do I connect these two steps? I snapshot the output of step one and give it as input to step two. So by having this kind of flexible data management, you can solve the how do I run a hybrid pipeline problem. You just take the output of step one and feed it into step two. And then if a pipeline produced an exciting result, how do I reproduce it? I take the code of the pipeline, which I have committed in Git somewhere, and it's a Python declaration, as Maven code demoed previously. I feed it the exact same input, somewhere else even, in another cloud, one cloud that may be faster, may have more GPUs, may be easier for me to use, and I expect the exact same results. So this is it. By being able to handle your data sets the same way you handle your code, essentially data commits, you can reproduce the pipeline in another location. We sit underneath your volumes, and we synchronize all state. We synchronize data among locations in a peer-to-peer way. So this may sound interesting, right? And you may want to try it out. Okay, so what are next steps? I'll come back to this. So how do we modify the model? There's usually 3 stages in building an ML workflow, but you know better and you can correct me. First step is how do I develop something, then how do I train, then how do I deploy? And people would like to develop locally on their laptops. That's where it's easiest for me to develop. But I need to train at scale, so I'll use a big cloud like Google's and use lots of GPU-enabled instances. And then I need to deploy in thousands of locations because I do autonomous cars, and they need to run my models. Where's my data? I keep all of my data in a single data lake. And this suffers for the reasons I explained previously. What's our approach to this? Instead of having a gigantic reservoir of data,
you can still deploy your pipelines in the same declarative way and use the same APIs. And you bring your data where you need it. This is the more technical picture. The there's kubeflow orchestrating, instructing Kubernetes to orchestrate your workloads across all locations. The workloads use the same declarative Kubernetes-based language to do that. We make kubeflow data aware. What does data aware mean? We contribute code to kubeflow, so it always uses persistent volumes. It's not, excuse me, it's not Aricto-specific code. We contribute code to kubeflow to always use persistent volumes. But then Kubernetes, persistent volumes is this PVC word over there. Okay, but then Kubernetes has a pluggable storage driver interface they call the CSI, the container storage interface. We are an implementation of the container storage interface. We use the container storage interface to orchestrate your local storage wherever you are, and we bring this peer-to-peer data synchronization magic. So this is how it works. And now you may want to try it out. So what's next steps? Next steps is we're super happy to announce, and you should see it on the Kubeflow blog, that we have a packaged version of Kubeflow. We call it Mini Kubeflow, which is not a very, let's say, original name, because you've already heard of Minikube, right? As a way to spin up a simple Kubeflow deployment locally. So we've seen that one of the major hurdles in getting started with Kubeflow is how do I install it? So we have taken the latest Kubeflow release, 0.4, and we're now working to package the latest 0.5 master, what's now being prepared. We have put it in a virtual machine image. You can download it. It's 2 commands. And you can run it locally. So we have a workshop at 5. Please be here if you want to know more about it, where we'll be demoing how this works end-to-end. So that's the overall idea. You have a very simple way of spinning up a local Kubeflow cluster in like minutes, if you omit the original download part. This is it. If you want to ask any questions, I don't know, am I out of time? No, I'm not. Okay, so the question was, do we synchronize data on demand when the data is requested, or do we do it continuously, right? So the difference in our approach compared to a traditional active, passive, primary, secondary replication approach is that we don't replicate data. We do not store your data. We do not replicate to your data. What we do is we sit by your data, by your primary storage on the side. We snapshot it periodically by extracting what has changed in a differential way, so it's super efficient. And then we give you a way to essentially declare the data you're interested in. Someone publishes data sets, as in publishes a bucket, makes it accessible, and then other people subscribe to this bucket. So by having this kind of publish and subscribe semantics, you can declare the kind of data you're interested in, and this brings you in the swarm. It's an actual swarm, like a torrent swarm, of people interested in this data, so you then start to synchronize. And we do it in a way that's actually authenticated and private. So it's not just public exchange of information. It's you have to prove to others that you're allowed to be part of this swarm, and you take tokens, and we establish encrypted links. There's lots of technical stuff, but the overall idea is there's full access control lists of who shares what with whom. Can you repeat the question? Sorry, I missed it. Okay. Yeah, I get the question. No, we won't work with your data if it's just directly on the object store. We use the object store for our purposes. We maintain our format in the stored data, so we can then synchronize it this way. So essentially, there's got to be a first ingress step. You continue using your data lake any way you like. We don't touch it. But the very first step in your pipeline is ingressing into the pipeline, into us, the subset of data that this pipeline is going to work with. And then we give you a very efficient way of snapshotting it. And this is what we will be demoing on mini kubeflow in the afternoon.
How do you interact with the PVC and PV API in Kubernetes? Is it you create a new class, or is it kind of hidden behind the scenes and reading from the Kubernetes API?
So the question, oh, you heard the question. The question was, how do we integrate with kubeflow, and how do we interact with Kubernetes, and how do we interact with Kubernetes' creation of PVCs? So we are a CSI plugin. Kubernetes says, I want a new persistent volume of size 100 gigabytes. We annotate the volume and give it extra information from where to clone. So if you pass us an annotation that says, I want you to clone from this data set, when we create the PVC, and we instruct your primary storage to create the PVC and then hydrate it, we do all these things, but Kubernetes doesn't know about this, then you just mount your PVC. So you don't see us directly, you see us as a CSI plugin. And we extend kubeflow to pass these kind of annotations to lower layers. Does this answer your question? Ah, okay. So, yeah, I have the exact answer to this, and we can demo it later. Okay, the notebook UI, when you request a notebook, will request a PVC for you, and we will dynamically provision the PV underneath, and the PV will be bound to the PVC, and you as a data scientist doesn't have to know anything about this, and this is important because if we get data scientists worried about PVCs and PVs, we are not in a good place. I think that's the general idea, right? We don't want people worrying about PVCs and PVs and Kubernetes and pods. We want them to see a uniform, notebook-centric interface in kubeflow. Any other question? Am I out of time? I think I am. Okay. Thank you.
Yeah, we need two mics, so one I hold and then one.
First, then? You guys gonna make me go first?
I think maybe I need some help. Stop. Hello? Check, mic. Yes. Yeah. Thank you. Hello. Hi, welcome to the panel, Why We Are Exploring Kubeflow. My name is Sumi. I'm the founder and CEO of Dream Job. It's a LinkedIn for tech talent, tech professionals like yourself. I'll be moderating the panel, and I have the local experts, machine learning experts from the LA region. They're here to share their experiences about why they're exploring the kubeflow. So we will start by having each one introduce.
The Somebody had been mentioning airflow at one point. I didn't look at that too deeply. I know that's, you know, one competitor for, I guess, the space in the DAG aspect of it. But when I saw Kubeflow and I talked to Josh, it seemed like they were really hitting a lot of the points just right out of the box. I didn't really think I'm going to do a shootout between more than one product. You know, a lot of what our needs are based around is the openness, the ability to tinker with any part of it. There's no real sort of lock-in to any format or whole stack at once. We are a polyglot company. We have a lot of different kinds of code that goes in. So, you know, for us, being able to drive through something that's, you know, from the onset, open and embracing different stacks from TensorFlow and MX and PyTorch and whatever you have, using the Jupyter Hub as a basis to have data scientists create and deploy their code and build their models from just a notebook was also, I think, really a great approach to integrate right into it. So that just attracted us right away to try it out.
Let's see. I think some of the drivers for me, it was a little bit strange. I didn't have a whole lot of alternatives. I just sort of had to make my own alternatives for deployment issues and things of that nature. But one of the things that really drew me to Kubeflow was the kind of unique situation where I was in, where I was literally kind of teaching people how to do what I did in different contexts. So being able to just teach people Kubeflow and how to use it was just a huge help, because it gave me like a formal way of going about things, like a repeatable process that I could just hand to each person that I was doing advising for. And then personally, it just made it a lot easier. I didn't have to worry about the mental overhead. Yeah, I think the big driver was probably just ease of use and just cost effectiveness of it. I mean, I used to be really big on using Amazon, but I got invited really early to use the Google Cloud, and back when it was in beta, but it wasn't quite as fleshed out back then. It didn't have all the technical documentation. So I ended up depending more on AWS, but as time went on, I found that Google Cloud just kept providing superior options, and then Kubeflow showed up and just made my life so much easier.
Right. So going back to you were saying of like how and when, right? So that's the biggest question. So yes, the Kubeflow is going to save a lot of time, a lot of resources. It's going to make life very easy. But then how and when? That's what you asked. So what would be like, what would be the things that would push the needle for you in your projects to say, yes, Kubeflow, I can start using it? What would be those? Is it like still, is it too early, or you want more better, like, you know, tutorials or more use cases that are aligned to your business needs, or what is that would push the needle for you? And I'm sure like that's the same for everybody in the audience who's looking.
Yeah, again, so we have, so first, what kind of models are we running? So we're running object detectors. So we have, you know, primarily this security vertical that we're going after. We also have this healthcare vertical. So, you know, a storage unit complex doesn't really care about pose estimation, you know, where you get like the skeletal points on a person, but a hospital would. So we end up having to support a large number of models. So we don't have a large team that's tinkering with all these knobs at the same time. That's kind of not our problem. It's that we have so many of these analytics that we, you know, this is another conversation, but they're black boxes to us that we need to enable as a feature set in the product, and it needs to be out yesterday. And so for us internally, managing all those different models, it's, you know, Derek found, you know, some model that some kid from India did, and it's amazing. Okay, like let's pop it in, let's retrain it, let's get it out. So that kind of workflow is amazing right up to the point for us of deployment. So Kubeflow is running internally. We have, a little mini data center in our office, and so it's running there. We're doing the training there. We foolishly bought a big machine that does all our training. And so the biggest driver for me, or the biggest, I think, push to like, let's get this full flow working in production is the edge computing component. So not all of our customers can update at the same time. Not all those devices are connected to the internet at the same time. Those connections to the internet, I don't know if you've ever tried to get fiber in Kentucky, but it's pretty difficult. So those kinds of problems are, I don't know if it's under the purview of Kubeflow to do this. But at the moment, that's our biggest pain point is like, how do we deploy this thing? When do we deploy this thing? How do we make sure that that model got down there? What version of the model are we running? Because, for example, we try and train, I mean, per camera model. The ideal scenario in edge computing is, okay, so in our world, we have a camera, we have a local edge device where we're doing the compute that's, and it's on the customer's network. And then we have, we go out to the cloud when we need to for them to go view the cameras and metadata, whatever, just visualize it. So if we have a model running on the camera, or some of these cameras are smart beyond, light motion detection, like they have decent chips on there, and, it seems like that's where the world is moving. So how do we manage that model? How do we manage the training of that model there, by the way? Because if we took all of these models and actually had to go train them, the amount of time it would take and the compute it would take in the cloud would cost us too much. So if we had, it would break our business model, in other words, to go out to the cloud and do all this stuff. Not just in the training, but also in the inference as well. So managing all of these different IoT devices, being able to identify them. So this is a camera, this is an edge device. This edge device is small and has X and Y capabilities. So we can run OpenVINO on an Intel I series, but we can't run, I don't know, some of these like GPU-enabled models. I know that the Intel one can work on a GPU. I'm just saying, if we don't have that there, let's just say we have an i3, I can only run this subset of models. Defining those and making sure that the right model gets down to the right edge device, because if I deploy, let's say I do some kind of federated learning for a small retail store. They have 8 cameras, all different positions. So we can kind of use the data from all of those 8 cameras. And that would be an amazing model, just customized to them. The detections are going to be great. False alarm rate is going to be really low. They're going to be really happy with this. They didn't even have to buy new cameras. These things were installed in the 80s, and they work great. But if I deploy, somebody else's model to that on accident, or the training doesn't go well and I don't know about it, and there's downtime there, especially in the security, with the security use case, like that's just untenable. So it's really all about the edge computing that makes me really nervous about getting that system up in production. Because if I have all these edge nodes, which you could do, you could run this kind of system where you have the master nodes out in the cloud, and then each edge thing is kind of communicating back home, and we kind of do that already. But to rely on Kubeflow at this time for that piece, I think would be unwise. However, I don't think too that there's a lot of business value in us creating like this kind of DAG pipeline. So if one of our teams came up to us and said, "Hey, I built essentially Kubeflow," I'd be pissed. Why would you do that? There's no value here to this. I mean, it's almost like, at least for us, with some of these commodity models, like these object detectors, like we're not in the business of creating novel model architectures. Like, we're not going to win there. We're too small. We don't have enough capital. Like, we're going to lose that game. So the quicker we can get these kind of state-of-the-art or latest state-of-the-arts into a pipeline to be retrained and redeployed, the better. And Kubeflow, like, I hope that that's what this project becomes, and would love to see that and help with that as well. Sorry, that was long-winded.
Yeah, we're also constrained by a small team and a lot of projects, but we look for opportunities to tie together, a lot of the pieces that are waiting for time, development cycles. And right now we have sort of a backlog waiting for Istio to get deployed on our clusters. Kubeflow is built on Istio, and that's a great opportunity to start putting that into production too, and getting some of the backlogs in data science activated as well. So that's one of the pieces I'm thinking of now, and it becomes kind of a DevOps concern too. We need to be able to spin up multiple clusters so we can test our other applications that may or may not need to be rebuilt on the networking layer but that's sort of where we are now. We're kind of ready. We're sort of, you know, wrapping up a round of deployments, and we'll probably end up concentrating on this conversion with Istio and using Kubeflow at the same time, since, you know, there will be. And yeah, I would say we're pretty much ready in about a week or two.
I would love to see what you were saying, touching on earlier, more tutorials, more, and particularly aimed at how to address what he was talking about embedded systems, machine learning embedded systems. If you put out more material like that, that would make my life a lot easier, because then part of my job is also instructing others and teaching them how to, you know, replace all of us, and so that they can go on to do the same thing.
And I think they were talking about, like, you know, a lot of meetups and local communities coming up, and if you guys want to join and take leadership, probably that's a good place also to learn. So now, opening up for, I'm opening up for the Q&A, and so whoever has questions can stand up, or and then I bring the mic to you. Oh, so is this the mic for the Q&A? Any questions?
Can we get a pity question?
Thank you. And please give a big applause for the panelists.
Ask myself a question? Like, are you amazing? Yes, I am.
Kind of a question.
Thank you. Thank you for sparing my self-esteem.
I'm curious about the edge computing of ML models. Like, how much of the training do you do on the devices, and how much is it like you train elsewhere and then ship the model to devices? Like, what would you say is the trade-off, or is it like completely, oh, we're training on devices? Yeah.
So this is going to be embarrassing. You guys are going to know how bad this is, but this is where we're at. All right, so everybody gets the same basic model. And then over about a week, we go, and if we have the bandwidth, which we always require for like the first week, we say like the system's training, we'll actually go out and talk to a bigger system. So we'll go like out to the cloud and say like, hey, you know, something nice like YOLO or whatever the case may be. What is this? So most of our IP is around like this kind of like lightweight algorithm that doesn't require a GPU. Again, this was somewhat foolish given where we're at today, but 4 or 5 years ago, this wasn't clear and wasn't available. So, I mean, we did all this work that like, you know, Kubeflow is doing now, and look at it and think like, oh man, not only did these guys do it, they did it like way better. So everybody gets a basic model. And then when we train on the CPU, it's like we're maxing out each of these boxes because everybody wants to, you know, spend less money. So how many cameras do you have? That's the kind of box you got to buy. You want to add more cameras or more compute, like you got to buy a different box or a bigger box. That's kind of how it is. So I don't have a lot of room. So I can't actually do inference and keep all the cameras up and train at the same time. So everybody gets a basic model, like you pull down your kind of basic model. And at this point, we have better ones. So it's like, okay, this is an interior model. This is an exterior model. This is an interior of like a data center. Okay, this is an interior of a storage unit. So they'll get that kind of basic model, and what we're working towards and what my end goal would be is every camera gets their own model. That would be the ultimate. We would get a lot less false alarms, and that's coming, and it's just difficult to do. I mean, I think sometimes we get so I look fondly at like cloud computing because I don't often have a cloud, you know, and I think that it's really easy to get kind of lazy about the resources that you're using. But yeah, perhaps that's that's another discussion. But yeah, edge computing is it's harder. Yeah.
I also do edge computing. A while back I did a little bit of research and I found this weird, obscure, like Russian research paper about what they called binary or bitwise neural networks. It was like very fine, a method for very small machine learning models, very low energy, and that's what we use for our cognitive radios for spectrum management. So it's very, like what you want with cameras, we kind of have now with these radios.
Do you guys use specialized hardware?
Yes, we do use specialized hardware, so I mean, sorry.
Yeah, no, it's awesome. It's awesome. Do you guys use FPGAs?
When I train the initial, I'm sorry.
Thank you.
All right. Well, I'm the last speaker separating you from lunch, so I'll try and be quick and diligent. There's been a few questions around the background for people here, whether you're a machine learning engineer, data scientist. How many here are excited about Kubernetes, deploy to Kubernetes, are interested in CRDs? Great. So this will be a little bit sort of separate from the previous conversations. The previous speakers have done a great job talking about Kubeflow, why to get involved, why it exists. I'll re-emphasize some of those messages, but then I'll also dive into some of the things that Kubeflow uses to actually build and develop and deploy as an application to be Kubernetes native. All right. So Kubeflow is, as Jeremy mentioned, composable, portable, scalable. This is the SCaLE conference. But it's also Kubernetes native, and we'll dive into that a little bit, extensible, and open. And I think each one of these three things hopefully will give you further motivation to get involved in the community, as well as it'll make you a better partner if you're in a relationship, or if you're single, it'll give you better dating mojo. Guaranteed. Just seeing if people are paying attention. All right. So you saw this, Jeremy mentioned this already. People get involved in AI, machine learning, thinking they're going to spend all their time on the code, but in reality, where they spend their time is all this other stuff to make it happen. And that, in part of that article there, the hidden technical debt. So you do this work, and you have to do all this other supporting work to sort of make it a reality, which, why is that a problem? Well, you can lose a lot of money. So in that same article, I talked about one organization that lost $500 million in 45 minutes. Holy crap, that's pretty bad. And so they said as part of that, it was dead experimental code paths. Well, how hard can it be to find dead experimental code paths? Well, if on that previous slide, you saw your code and all that other stuff, if it looked a little bit like this, you know, try and find the dead, non-working cable in this mess, right? In reality, what you want is something like that, and that's where Kubeflow comes in, is it helps you build systems and scalable systems that look a little bit more like this. You could argue that you still couldn't find the dead cable path in this, but at least it'd be maybe easier and less onerous to actually read through all of the different cables in there. So that's kind of part of the motivation. Back to these three simple messages. Kubeflow is Kubernetes native, extensible, and open. You'll see that a couple more times. So what does it mean to be Kubernetes native? So here's a general architecture for Kubernetes. You guys have probably seen this 1,000 times. You got a master node, worker nodes, a bunch of things in there that'll schedule your containers. You have an OCI repo or your Docker repo that'll serve up the images. I haven't put in here the fact that somebody's actually built some code and had a Docker file and created that container. Thanks for that. And put it into the repo, but that's kind of a general architecture. To level set a little bit, what is Kubernetes? So in here you can see, you can probably read faster than I can talk about, but you got nodes, and they run pods. Pods created and managed by replica sets. You can do some of these things without, like replica sets, without deployments. But in a second, you'll see how those things help facilitate and help manage your workloads and help make running containers and keeping containers running happy. So that's some of the terms that I might use throughout. And eventually we'll talk about APIs, what they are, why they're important, and then get into some CRDs, which is custom resource definitions, which Kubeflow and other Kubernetes native applications make heavy use of. To re-emphasize a little bit more on Kubernetes APIs, you can sort of double click on each one of these and sort of have a pretty good conversation around what does it mean to be declarative as opposed to imperative? What does it mean to be asynchronous, level-driven, observable, et cetera, et cetera, et cetera. I'll dive into the declarative one and the extensible one. And again, this is just sort of re-emphasize this transformation that you're seeing within the community, software development, application development, corporate applications, going from whether it's monolith to microservices, but essentially going into the cloud-native world and quite possibly, presumably, the Kubernetes native world, and how you can take advantage of Kubernetes to help accelerate your application development, help you get involved in Kubeflow, and understand how Kubeflow is created. All right, so let's go into a deployment example and see what happens. So you have a YAML file, and you'll see a lot of YAML files as part of Kubeflow. You may or may not get involved with these YAML files, but it'll be good for you to sort of embrace it, love it, understand what they are. The first two lines there is just sort of the resource metadata. The next part there, actually specific metadata, is that object metadata, and then you get into a spec, and you'll see that a little bit later. I'll show you an example of a TensorFlow job spec, similar but different. And so what happens is when you say sort of kubectl apply to that YAML file, first what will happen is it'll discover the endpoints for the API server. It'll do an HTTP post. And then magically, I put question mark there because magically all these pods just sort of appear on worker nodes somewhere in the world. Now how does that happen? Well, here's a little bit more of a detailed view on what happens. So you hit the apply button on deploy. It hits the API server, says create. That will send a watcher event to the controller, the deployment controller. What it'll do is it'll sort of say, hey, I'm going to go create a replica set. And I'm just going to click through the rest of this because what you'll see is that each of these different controllers are looking for certain events to happen, and they'll get notified of an event, and when that event happens, they can do whatever they want. In this particular scenario, they're creating additional resources, which will then cause additional work to happen. So there we'll see the replica set controller doing its job, pod scheduler doing its job, the node doing its job, and those last two there, the update pods, that's actually updating the status of a pod resource that is being maintained by Kubernetes. So that's the end of that discussion there. What I was trying to tease out is, what happens with a YAML file, a resource definition, what happens with controllers. Now we're just going to go to fast forward into a TF job CRD. Can you guys read that one on the left? Awesome. So that's a 4-point font, but that's to give you an example of defining a TensorFlow job, and that one that you can submit. There's a bunch of arguments in there. I'm not going to go over all of them. If I went over, no, I can't do that easily, can I? I was going to show our wonderful documentation, and let's see if I go up there, here. So here you can see that this is up on our site, kubeflow.org and docs. You'll see TensorFlow training. What is a TF job? This is that in better print. You can see how you can pass in arguments. And by defining this YAML file, you can use kubectl to then send this in and have all that training happening, have all that magic happen. Again, I'm highlighting part of this, not only to show how kubeflow works, but if you have other corporate applications that you're in the process of transforming into Kubernetes, then kubeflow provides a really, really good example of how to do some Kubernetes native stuff and some best practices to take advantage of what it has to offer as a platform. And then this will go into all of the detail here. So you haven't, I don't think we've actually shown this, this website yet, but please go to kubeflow.org. Lots of great documentation in there. And again, this is specifically how TF job works. And as Jeremy showed in one of his slides, there's a lot of boxes in the architecture. There's a lot of components that are part of kubeflow. Not enough time here today to go into each one of those, but I'll go back to my presentation here. All right. Okay, so why is this important? So here's your general training process. You've seen some examples of this already. Defining the model, training it, having a trained model, deploying it, whether it's to private cloud, public cloud, you know, all that kind of good stuff. Remember back to seeing all those crazy cables in your data center. So you can start on a workstation. So kubeflow, and you have CPU, GPU storage, etc. But now imagine that you have a single cluster, but multiple deployments of kubeflow. It could be per namespace. So imagine each one of these belongs to an individual user, and you're doing shared resources across the bottom. Now take that out to imagine you have not only a single cluster, but you have multiple clusters, multiple Kubernetes clusters, either on-prem, VMware, bare metal, up in the public cloud. And you want to define and you want to deploy quite possibly not only this many kubeflow deployments, but also your corporate applications, leveraging the exact same hardware. So if you want to think about resource utilization, CPU utilization, et cetera, doing not only your artificial intelligence on that same hardware, but then also your corporate applications on the same hardware, then that's when you start to see that understanding the power of kubeflow, but then also being able to use Kubernetes and define CRDs to define your own resources and interact with that with an API. I know that earlier there was a lot of DevOps and a lot of hands went up. So you can search this tree of information, this tree of resources, quite easily once you understand what that looks like and how to start surfing these clusters. All right, so you saw some of these components already. I won't go into some of these details. There's more and more being added all the time. I actually don't even think I put up here ModelDB. ModelDB's been there for quite some time. It's from a community out there at MIT. Quite interesting. It's not a CRD, it's a service. But it's an example of this community, growing community, how you can easily add your own component and then to integrate with that component within your machine learning jobs, just sort of it's a simple sort of addition or modification of some of your code to then integrate with some of these services. A lot of key components, these were on Jeremy's slides as well, so I won't go into the details. I'll skip that slide. And then, yeah, it's extensible. So add your own Jupyter containers, your own controllers, your own pipeline components. You build your own standard pipelines. Come up with your own innovation. So there's lots of ways that you can get involved and you can extend kubeflow and make it available to your organization. And particularly if you're a platform engineer responsible for providing a platform to your organization, these are some of the areas where you can play in. And lastly, I flew in from Australia this morning, so that's why I might be a little bit sleepy. But that's what open roads look like in Australia. I don't see any dead kangaroos, but a lot of times you'll see dead kangaroos as well. It's a different story. But the community is very open. So, you know, if you haven't gotten involved yet, please get involved. If you are an innovator, there's lots of different platforms you can use to innovate. I work for Canonical and Ubuntu, and it's really easy to get going on Ubuntu and Ubuntu platform. We have a lot of tools to get you going. That's it. Sure. Yeah, shout. Yeah. Sure, sure. So CDK, canonical distribution of Kubernetes, or charmed distribution of Kubernetes. There will be a charmed version of Kubeflow. You'll see an example of that later today. Any other questions? All right. Be back at 1:30.
all the things that we've done in the community rather than Cisco. I'm not going to talk about Cisco.
Okay, gotcha. Okay.
Basically, we talk about how we've engaged so that it's like the people in the room who are from different companies, they can say, oh, we can then do the same way.
Okay, sounds good. Okay, I think we're going to take a couple more minutes to let people filter in back from lunch. But then we're going to hear from Debo Dutta from Cisco. And I'll introduce him when we're ready to get started. Thanks. All right, welcome back, everybody, or hello for the first time if you're just getting here. I think Josh Bodum, who is our event organizer today, may have gotten stuck at lunch, as I'm sure some of our attendees have as well. But I'm really excited to hear from Debo Dutta, who's one of our, oh, there you are. Hi. Well, I'm just going to present anyway. He's one of our core community members in Kubeflow, and he works at Cisco. He's here not to talk about how Cisco handles machine learning, but instead how they've engaged with the Kubeflow community and how they've helped us build the project what it is today. So thanks, Debo.
Thanks. Yeah, and I'm sure after lunch I'll try to not bombard you with too many slides and demos. Hello, can you hear me? Yeah, I don't know how to put this, but yeah. So I've been an engineer at Cisco. I'm originally from. I've spent a lot of years at Southern Cal, went to USC, and so today what we are not going to talk about Cisco and what Cisco does with AI, but just wanted to let you know that we have a diverse portfolio of products, and all of these products use AI in some form or the other. We have our own scars and pain points of, the AI ops, the data scientists. We have all of the above that we've talked about today, but we are not going to talk about the Cisco stuff. I just wanted to, and I'm sure there are many people over here who are from other enterprises. They're thinking about similar problems. So I just want to talk about why we chose Kubeflow and what was the rationale like exactly 1 year ago. So a year ago, when we were trying to build our own machine learning pipeline, in fact, my team, we were trying to build a machine learning pipeline, and then we noticed Kubeflow. I talked to Jeremy, and we said, okay, we went back to the team, and I said, we should actually just scan our own project and just contribute and start building with the community. It might take a little longer time, or it may not even take a little longer time. We don't know. But when we saw the right kind of people in the community, so our metric was, who are the people in the community? We saw Canonical, Red Hat, Google. They were all in the community, so I said, okay, that's a good community. It's going to start, and it's going to take off. So that's what we, and so right now, Kubeflow is our pure open source effort. We do not do anything internally
Everything is from day zero external facing. And so that's why I just wanted to talk about how did we choose what to contribute in, and so that many of you who will go back to your own enterprises can think about what your needs are and how you can help either use Kubeflow, or you can probably leverage Kubeflow and then contribute back to Kubeflow in many ways. So there are multiple ways you can look at our journey and figure out what works best for you. So we saw, when we looked at all our products and we talked to a lot of our customers, so I personally talked to a lot of our customers, everybody has the same pain point. They are not completely cloud focused or completely on-prem focused. In fact, they typically deploy their production workloads across multiple clouds, and they have all kinds of pipeline, the life cycle challenges, and you can recognize, at least with most of them. So the biggest problem is that when you try to manage the entire life cycle and you try to manage the cost of running the entire life cycle across many clouds, the different tool chains that different cloud providers have and the on-premise software has it can be a bottleneck. So what we felt is Kubeflow is the right platform because directionally it abstracts all the machine learning infrastructure from the end user, and we'll talk about, and there are different personas, and that's when you can make rapid progress. So if you want to accelerate your teams, your customers, your partners, whoever, in machine learning, in the long run, it's not just about data science, it's not about DevOps, it's about the entire life cycle. Please do consider Kubeflow and contribute back. So there is one use case when people say that, oh, but cloud provider X already has a cool ML tool. Why can't you use this? So if you look at some of these use cases in industrial setting, let's look at simple things like microscopy, where you can go to openmicroscopy.org and get to know the entire use case without having to take notes. But there are, if you look at these high throughput imaging systems in industrial environments, they can generate 50 to 100 terabytes of data a day, depending on how many of those machines you're leveraging at one point. So the question is, how do you determine artifacts? It's not about figuring out which a cat versus a dog, which is the quintessential ML use case that half of the talks have. It's about real industrial value. So in these use cases, you just cannot connect to the cloud at that speed. So you would have to do both on-premise and cloud, and you would have to always think about consistency, not just how something works well for you today, but as you grow your businesses and span across multiple cloud. So when we looked at our problems last year, when we started off, we said that we are going to simplify our customers' journey by betting on open source, by looking at open source products that come from partners that are known to do good things in AI, and that can help both the two sides of the organization. So typically in an organization, you have the scientists and the engineers and the IT, enterprise IT somewhere trying to figure out both the sides of the same coin. And so we bet on Kubeflow. So that's pretty much the motivation. And if you have a different motivation, would love to hear post the talk. But so this slide deck is evolving, but this was something that we felt that Kubeflow is really good for the basic Kubernetes integration and the essential ML tools, because that's going to be commoditized. It is best to pay your technical debt upfront. I'm just talking on behalf of any enterprise who wants to accelerate themselves in machine learning and focus on your line of business applications, which is the top layer of the stack. That's where you want to focus all your energy, and let open source and let's build very strong, big open source communities to deal with the other layers. So this is a proof point that we've done. So our goal is, so from our team's charter is make Kubeflow really good, but ensure that you have a consistent experience whether you're in the cloud or you're not on the cloud. And we've kind of worked with Google's partner engineering team regularly to ensure that we have the uniform UX. For us, that is the most important thing, and we will keep highlighting that in the talk. So in order to kind of get into the community, we were new to the community, and we didn't know exactly what would be valuable. So we asked Jeremy and David, who's, I don't know if David is in the room, David Aronchik. So we said, where can we help the community rather than what can we, this is what we want to build. So effectively we said, okay, let's see what an ML training job looks like. It looks like some kind of a Keras or TensorFlow workload, and then you go through the TensorFlow toolchain, you compile it, and you, through an operator in Kubeflow, you run the job on Kubernetes pods. So this is like everybody in this room probably knows this already. So then where do we contribute? I mean, so we realized that the TF operator was really robust and very good, but there was some gap in PyTorch. And we also noticed that at that point, Kubeflow had a really good project that was just kickstarting called Katib. And so we were looking at all these things, and we kind of took the community guidance, and we said we are going to first improve the PyTorch operator and make it as good as the TF operator. So that's what we did. And instead of, and that was really good because we started seeing a lot of teams who were not wanting to use Kubeflow because, oh, Kubeflow is only about TensorFlow. Then we said, no, Kubeflow is not about TensorFlow. It's about any kind of machine learning backend that you want to have. And so this was a good step in that direction. Then when we started playing with Kubeflow a year ago on premise, we said, how do we know this stack is performant and it matches up to our expectations? So we realized that there was a big gap at that point, and the gap was benchmarking. If you want to have an on-prem solution, what is your benchmarking story? So we said we'll create a benchmarking pipeline, I mean, an entire module for it. So we contributed that, and in fact, we feel very good about it because not only can we use that in Kubeflow, we can connect other open source communities together. Because if you Google for mlperf.org, that's another benchmarking community that's again spun up by many companies. It's basically to come up with industry standard deep learning benchmarks. So now our goal is to ensure that we can run some of their reference workloads on KubeBench, on a Kubeflow cluster, no matter where it runs. And another thing that when we looked at Kubeflow, we realized, okay, remember the slide that I showed you? So you have the basic tools that integrate machine learning workflows with operators into Kubernetes. But typically, most of the time, whenever you start ramping up your data science teams, most of the time, people will take existing models and fine-tune them. I think this was also mentioned by the panelists from Wiser, that many people do not have the skills or do not have the time or the resources to build models from scratch. So hyperparameter tuning and looking at some of the advanced art like neural architecture search is actually very important. So for those who don't know hyperparameter tuning, a simple way to understand is, suppose you take a deep learning model, you've specified the models, but you do not know how many layers to use, what kind of filters to use, what are the filter sizes in a typical CNN, and you want to iterate and figure out what is the right variant or the qualities of the right model that you want to train. This is not even like figuring out what model to use. Like given a CNN, if you've decided you want to use computer vision and you want to use CNN, what are the qualities of the model? What kind of parameters would you train? So that is hyperparameter tuning. By the way, the hyperparameter is not the same as training the model. And if you want to take a step forward, on one hand you have hyperparameter tuning, the other hand you have neural architecture search, which means I don't know whether I want a CNN model that's specified already in the TF examples. I want to start building my model from scratch. I may have some constraints. And that's when you actually build the architecture. And that field is called neural architecture search. It's relatively a recent field, and there's a lot of activity in the industry. And what when we saw CATIB, the hyperparameter tuner, we said, why shouldn't it do neural architecture search? Because we were already, independent of Kubeflow, doing our own research and putting out open source software to do this. We said, we are going to make this happen inside CATIB. That was our promise. I know Jeremy and I, we've talked about this promise for many months now, not years, sorry. So by the way, one of the things that we did along the way was we also contributed the Bayesian optimization for CATIB. And right now, this is in alpha, but we are contributing all the neural architecture search stuff into CATIB so that CATIB becomes a general AutoML system. And then we can have, then we will be much closer in terms of parity between the cloud, the tools from the cloud providers and on-premise. And so these are some of the ways that I think your companies, or if you're from academia, you can contribute and make this community a really robust community and make Kubeflow, the de facto ML platform for Kubernetes, as opposed to building yet another one. Otherwise, if people will keep building tool chains, and that's probably not that valuable. And the bigger the community is, the more things that you can use, you are going to actually have a more vibrant ecosystem, and it's going to just amplify your effort. So one of the things that we also recently started participating in the community was helping folks in actually talking to customers and doing user surveys. So you've probably seen this from Thea already, but essentially we realized that this community, as it grows, the needs will change. So our goal was to see, today let's take a snapshot, let's help in the user survey. Let's actually do the user survey every 6 months to see the dynamic nature of our community and how it changes, and so that we can build the right things. And essentially what we realized is, when we talk to a lot of people, and even internally, a lot of people want on-prem to be a first-class citizen. So that's why we created a CUJ proposal, and by the way, it's not a Cisco proposal, it's a community proposal. We expect everybody to contribute to it. And there was nothing in the community, so we just jump-started it. That how do we make on-premise a first-class citizen? So for example, how do we, the baby steps are how do we address bare metal install and management challenges, then how do we ensure storage integration, as Arecto talked about, and then how do we ensure the same user experience? I think that's very hard to define very precisely, because the community itself is changing and it will keep improving. But as the community evolves, how do we ensure seamless UX on-premise and in the cloud? So I think only when you have seamless UX can you have seamless hybrid cloud. If your on-premise UX sucks or it's not as good, you will not have the hybrid cloud experience. And if that's what your business requires, you need to enable that. So we've taken some baby steps. I don't want to go into the details, but most importantly, what we want the community to do is to join hands and do a lot of testing, figure out what your use cases are, talk to the PM community, give feedback to the on-premise community. In fact, we want to create a subgroup so that we can actually help prioritize this. It's not going to happen just with one participant in the room. It's going to happen when we all join hands to make this on-premise system look as good as the cloud offerings. And of course, there's a lot of testing involved, there's a lot of integration involved, a lot of solutions need to be done and a lot of good documentation that we need to do. So I think Kubeflow is a really good, it's a great journey, and we believe that we will keep improving the community, we'll keep fueling the community, and I think it's going to take off. There is no doubt in our minds. It's just that we want more people to join it. And that's pretty much what the reason why I'm here to talk to you about Kubeflow. So I didn't want to spend much time because everybody's just after lunch, but we still have 6 minutes for questions. Yes? Critical user journey. Yes, sorry, I should have mentioned that. Any other question? Yes.
I think I asked this question in a previous talk, but I'm curious, your use cases are very interesting. What about non-deep learning use cases?
So that's a very good, so the same, I think we've all felt the same pain points. We have a lot more, and I mean, personally, when I look around and talk to our customers and partners, we have more non-deep learning workloads, and that's one of the things that we will also help do. So your points are really well taken.
I have a question for you. It's a question / a request for feedback. What do you think are the most effective ways to engage with the Kubeflow community as both like an advanced contributor and as a new contributor starting out?
So as an advanced contributor, the best thing is to actually attend the Kubeflow Contributor Summit and just socialize and see where you can help. I mean, go with an open mind. So that's the advanced contributor pitch. For the new contributor, I think the best way, so a lot of people within even Cisco have said, hey, you're doing Kubeflow, I want to get involved. I would say install Kubeflow, run a simple application, and then you'll feel some of the pain points and start attending the group meetings and actually just be on the Slack channel and ask questions. Ask a lot of questions and ensure that you can run Kubeflow first. Then you can contribute something to it.
Thanks.
What are some of the problems that you've seen running it on bare metal, and what are you trying to fix?
Yeah, so if you think about Kubeflow today, the bare metal support for some of the components like pipelines and some of the even operator support, you have to do some extra work. So for example, you have to do the storage integration. So it depends on how you're trying to use it, because pipelines works, but pipelines is a very abstract view of your workload. But if your workload is somewhere else, you need to bring it close to you, and that's some of the, yeah, so mostly around, actually these are not major problems, but it's about making the UX better. They are like small issues. You have to fix your storage backend. You have to ensure things don't, you're reading from the right place. So a lot of these things will be worked out. I'm sure the community is going to smoothen it out in the next few months.
So this network architecture search in Khatib that you're talking about, is that leveraging any of the other existing open source tools, like Keras has AutoKeras, which does this, or is it just like a separate effort?
So I think it's been a separate effort from scratch in the Kubeflow community. In fact, what we've done is we built it in a pure. See, most of the other efforts, they are not native Kubernetes efforts. So we wanted to do it from scratch. So we had our own code base too for some of our own algorithms, and we've ported some of the existing algorithms into the framework. And so we wanted to be a native Kubeflow tool. Yes.
Not specific to this topic, but I have general question about the open source aspect of the Kubeflow. If you look at the current installation guide, you see it uses KSONet, the KS interface. But when I try to go to install case, yes, it is there, but I also see the node that it has been, it is defunct. There is no more active deployment on that. So that's one question, like, are we going to update all our nodes to use, and I use the UI work just fine, but as I want to be more command line.
No, so that's actually one of the things that the community is really working hard towards, is to have better documentation and better, that's what we meant by better user experience. When a new user tries to learn and jumpstart, it's still not as friendly as it could be, especially for the non-ops folks, like the pure data scientists.
Agree, and I'm happy that you already discovered that as a problem, so knowing that it is a problem is important.
Yeah, we all recognize, actually within the community we are very open and we recognize all these problems and we are working very hard.
Yeah, and the second part I wanted to ask is, like, what is the way to give feedback about anything so that it's just Slack?
Slack works, and file an issue. If it's a real problem, file an issue.
It's more like a feedback, like what these kind of things, like user experience and all that.
Yeah, I think Slack should be good.
Okay, great, thanks.
Thanks. I do want to emphasize that filing an issue is the easiest way to get your problems visible, and actually filing an issue and then referring to the issue from Slack or from the mailing list is like A+ contributor work, so please do that. Yeah. Oh.
So I have a silly question. Do you have any examples, maybe like some YouTube videos where you show working through an entire example, or do you have a GitHub thing or something like that?
Yeah, so there are community examples, community GitHub stuff. We also have published on our GitHub an entire example. So you can, but I would recommend first check out the community examples.
Yeah, you can find community examples in Kubeflow/examples repo. No. We don't have, but yeah, just on GitHub, it's the best place to look at all of them, both coming from the Google team, but also from the community.
Thank you again.
Yeah, thank you. So next up we have Rita, Zhang, and Zertek from Microsoft, who are going to talk about scaling and testing experiments on Kubernetes using Kubeflow, Helm, Virtual Kubelet, and Azure Container Instance. While they're getting set up, I have some questions for the audience just to get a sense of like the open source experience here and what matters most as far as like adopting open source projects for you guys today. So how many people regularly use an open source tool as part of their workflow? Awesome. That's a lot. I'm wondering, so as far as documentation, examples, or kind of basic API stability, which of the three are most important as you're considering getting started with a new open source tool? So documentation, any hands? Most important? Okay. How about examples? Okay, and how about API stability? Awesome. So all of them are important. We'll get working on all three of those. Thanks.
Hello.
Hello.
Right. Hey everyone. I know some of you guys asked for demos, so we will have demos. So it's gonna be exciting. So yeah, we're here, very happy to be here at Kubeflow Day, and we're going to talk about how to use Kubeflow with all the other awesome Kubernetes toolkits that you guys already love and familiar with. So it is about Kubeflow, but also in addition to Kubeflow, what are some other tools that you can use at your disposal? With that, all right, so early last year, OpenAI basically told everybody they were using Kubernetes for their ML trainings, and one of their largest clusters go up to 2,500 nodes. So that was really, really cool, and a lot of people were really impressed with that. But as you know, not every company can be like OpenAI, where they have a dedicated operations team to help support their data science team, right? So in this talk, we're going to show you guys some tools that you can use for your own organizations, where you can also do what Elon Musk does.
I would like to introduce Rita. Rita is a software engineer at San Francisco in Microsoft, and then she works in the Kubernetes Upstream Futures team. She contributes to the Kubernetes project and many other projects, and making it work great in Azure. Also contributing to our projects like AKS Engine or the AKS Azure Kubernetes Service.
And I would like to introduce Surtek. He is also a software engineer at Microsoft in San Francisco, and he also works on the managed OpenShift offering that we have on Azure, as well as the Azure Kubernetes service. So if you want to try it out, you guys know this guy worked on it. So for the rest of this talk, we're going to start off by talking about some of the typical ML workflows, and some of the shortcomings. And I know we already saw a lot of slides today. You guys probably saw a lot of workflow diagrams, so we're gonna short circuit that and skip some of that. And most importantly, we want to use this opportunity to tell you, with tools like Kubeflow, Helm, Virtual Kubelet, you can basically make sure that you enable your data science so that you can run your trainings and servings anywhere, right? Whether that's on premises in your own cloud, or you could run it in any one of the public cloud offerings.
Get this microphone close. We're going to have some demos. We're going to see image classification with Inception v3 and transfer learning. And then we're going to look in automating repeatable machine learning experiments with containers. And then we're going to deploy the ML components to Kubeflow, to Kubernetes. And then we're going to scale and test these workloads that we deploy with Kubeflow.
Okay, so by now, you really should know what Kubeflow is, right? All right, so we're going to skip this. And we all know it's awesome, yes. So how many of you guys heard of Helm? Oh, nice. So I don't really need to talk about it. But for those of you who might not know, it's basically a application package manager for Kubernetes applications. Now, we all love YAMLs, right? But what this allows you to do is package your application so that all of your nice YAMLs can be packaged into one application, so that when you share your application with other people on the team or with your customers or whatnot, you can actually hand them off to this Helm chart, and it will encompass. It will be composed of a lot of Kubernetes resources that your application requires, and you can actually manage the lifecycle of your application by using Helm. And we're actually going to use Helm in our demo to show you how you can package up your machine learning applications like any other Kubernetes application. So for those of you who might not know what Helm is, we're just going to show a quick demo of, or just kind of walk you through. So one thing that's really nice about Helm is that there's all these community-driven, community-supported applications. And in this charts repo, you can see all the popular applications that people have already created. So I'm just gonna like go ahead and show a WordPress application. And as you can see, for this particular WordPress application, you basically just have to define what are the resources that you want the WordPress application to deploy in your Kubernetes cluster. And as you can see, ingress resource, PVCs, secret services that you've defined in order to run this WordPress application. And what's nice about it is you can actually expose the configurable components of your application via this values YAML. And you can parameterize it such that you only expose the parts that you want your end users to parameterize and configure them. And this is also really important because we're going to use this in our demo where we demonstrate how you can use Helm charts to parameterize your experiments, your machine learning experiments. And we actually use the values YAML to drive some of those hyperparameter sweeping parameters.
And then next we are going to talk about the virtual kubelet. How many of you are familiar with virtual kubelet? Okay, so not that many. So virtual kubelet, VK, is an open source project in the Kubernetes upstream that kind of makes a virtual kubelet that masquerades as a node. So you can think of it like Kubernetes, but in the back end, you can do whatever you want. So in sort of way, so it's like it provides a pluggable interface that you can add different providers. So these are some of the providers that are there currently. You can have Alibaba ECI provider, AWS Fargate. There's Azure Container Instances, Batch GPU, Service Fabric, HashiCorp Nomad. And then today we are going to talk about the Azure Container Instances provider and how we can deploy containers from your Kubernetes installation to the cloud using the Azure Container Instances. So the workloads are not in your Kubernetes cluster, but it runs on the Azure Container Instances. But you can see them in your Kubernetes cluster because it's scheduled through the virtual kubelet. So we have a demo. If we can. Yeah. So let's do this. So the first step is basically, if you do Helm, is this one? Right, let's do this one. Full screen this one? All right, so we'll just run this through. So if you have the Helm binary installed, and if you do Helm init, it'll install the necessary components to your Kubernetes cluster. And then in this case, we already have it. So we do the Helm version, so you can have a client and then the server component. In the next version of Helm, there won't be a server component, so it'll just be on the client side. So like we talked about. Rita talked about earlier, we are installing the VK chart in this case through the from GitHub and the virtual kubelet, the organization, and then we are going to override the values.yaml that is when we specified. So in this case, if you do -f and then specify the YAML file, it'll overwrite with whatever you want. So if you're doing hyperparameter tuning and whatever, you can specify specific ones that you want. And then in this case, it installed all the deployments and then the pods. And then we do Helm ls to see that it's deployed. And then in this case, we do a get node. So the next step we're going to see is we do a get pod so that the virtual kubelet is running as a pod, and then in the last step you can see that it registered the virtual kubelet as a node type. So now when we create like a new deployment or whatever, we can say, hey, go ahead and schedule on the virtual kubelet, and it'll create something on the ACI, for example, or any of the other providers. Yeah, so this is like another screenshot of the last thing we saw. So you can see the virtual kubelet is registered as an agent node. And then if we describe it, I'm not sure how clear this is, but you can see the capacity is like so large. There's like 800 CPUs there. And then you can also have like GPUs and other resources there. So like I said, you can think of it as like a node, but the backend will go somewhere else in any of the providers. So for example, this is how you would schedule a GPU in Azure Container Instances. You add an annotation for the virtual kubelet.io GPU type, and then this is going to be the GPU SKU you want. In this case, it's K80, but there are other SKUs also. And then for the node selector, this is how you would schedule, just like you're scheduling a specific, like a pod to a specific node, this is how you would schedule in virtual kubelet. So if you say type virtual kubelet, hey, I want this one, and then you can have a node selector as like a Linux or a Windows node. So in this case, it's Linux, and then this is how it gets scheduled to virtual kubelet, which will create a Azure Container Instances instance, basically.
All right, so Sertaj talked a lot about Azure Container Instance. So what is it, right? So basically, it's a service that allows you to run your containers. So you don't have to worry about the underlying infrastructure, all the nodes that you have to manage yourself. All you need to do is bring your container, right? And all you need to do is tell it how much resource you need, and where's your image. And if you decide to use like files, you can tell it where the network share is. So all in all, it's a provider that allows you to run your container without having to worry about the actual infrastructure. And the other nice thing is it's created as you request it. So it only runs and charges you per second only when you actually request the resource, right? So if your container's not running, you don't have to maintain it and you don't have to pay for it. So why is this important in this scenario? Well, we worked with a lot of data scientists that were trying different experiments. Now, if you have ever had to create like your own cluster for your data scientists, obviously, a lot of times the experiments that they need may require many GPUs. Now, if you have to create a cluster and maintain it over time with many, many GPUs, that's very expensive, right? So with this, what you can actually do is you can allow your data scientists to schedule their experiments as they need, and they don't have to wait for other data scientists to finish their experiments first so that they can run theirs, right? So this actually gives them a way to schedule the experiment as they need and scale out as they need to perform the experiment. So let's take a look at what VK and ACI looks like. Can you guys hear me? All right. All right. So as Sertaj mentioned earlier, here, as you can see, because I pre-installed the virtual kubelet Helm chart, I basically now have a virtual node, right? So with this, right, as you can see, because the virtual kubelet node in this case is actually presenting itself as a virtual node, but it's actually running on Azure Container Instance. So now, to me, the cluster operator, it looks like I have 100 GPUs at my disposal, but I don't have to pay for it, right? Because I'm not running anything. So now let's see how a developer or a data scientist can actually schedule a container or a job or a pod in this cluster, but really it's running off of an Azure container instance. So here, as you can see, I have the often demoed Nginx pod, and all I'm doing is, hey, I'm telling Nginx I need this much. I need to run this container in a node called virtual kubelet, and I want to be able to schedule this pod there, right? And so once this particular pod is scheduled, and as you can see, it is actually scheduled on this. It's actually maybe this looks better. Yeah. So it will show that it's actually running on the virtual kubelet node, not one of my nodes in the cluster, as you can see here. And then it gives me a public IP that I can use to actually reach my Nginx pod. And there you go. So all you have to do is schedule this pod like any other pod, but the actual resource that is running, it's off of Azure Container Instance. And as soon as I delete this pod, it's no longer running, and I'm no longer paying for it. All right. Okay, so I might just like maybe skip this, because as you guys see, we've seen a lot of diagrams. But basically, let me just quickly walk through this. In a typical machine learning workflow, right, you have some data set that you want to train on, and you want to be able to run training, whether that's sequential or maybe you have some hyperparameters that you want to experiment with, and maybe you want to distribute that training. But those are the parts where it's a little bit difficult, especially if you only have one machine, or maybe you're in an organization you don't have that much GPU, right? And so the other problem that a lot of data scientists face is, now I have a bunch of models, how do I serve it, right? And how do I make sure my application, the serving application, is scalable? And so these are the questions that often come to us coming from the data scientists. So for our particular demo, we're going to use the same workflow, but basically we're going to find a celebrity. So the problem is a celebrity that we have, and we have a bunch of people who are not that celebrity. So basically an image classification problem. And what we are actually doing is we're doing transfer learning using Inception v3, which was previously trained with ImageNet. So taking that, what we're doing is we create our own data set of celebrity and not celebrity. And we use transfer learning to train the top layer so that we can actually classify for our particular celebrity. And in order to make our model more accurate, what we are doing is we can run our experiments repeatedly with containers, and because we're going to use Helm and virtual kubelet and ACI, we can actually parameterize our experiments and run them in parallel. And we can visualize the training results as they're running with TensorBoard, because all of that comes with Kubeflow, right? And so last but not least, we have a pipeline with Kubeflow pipeline, or Argo of your choosing. So you can actually create that pipeline, and once your model is done, you can use a pipeline to trigger the serving stage of your pipeline, and then the serving stage will basically use the model that you want to use. So let's look at the demo. All right, so here I have just a simple Docker run command, and all it's doing is running my code, right? So I have a Python code that basically takes Inception v3 base model, and I tell, in my code, I go retrieve the images that I want to use for training, then I create some distorted images for my training, and I create the last layer before the actual training starts. And as you can see here, I'm running this on a single VM, and it's using K80, Tesla K80 for my GPU. So all this is showing you is it's some container running the training portion of the experiment. Okay, so next, what we have is the serving part, right? So once you have a model trained, you obviously want to serve it, and there are many ways to do it, right? You can create your own Flask application and just serve your model that way, or you can use TensorFlow serving or Selden, however you want. So in this demo, we are actually using TensorFlow serving because it just works out of the box, right? And all of that is in this demo. All right, so what I'm doing here, and again, we're not even on Kubernetes yet. We're just using Docker right now. So here, what I'm doing is I'm using the TensorFlow serving base image, and I am basically using it to create my own image using the model using the transfer learning model that I've already trained. And then here, as you can see, I'm creating the serving server, and then once that server starts, it's running off of port 8500. And then next you'll see I'm running some Python code that basically grabs an image and going against that TensorFlow serving endpoint. And here you can see is a code that is doing the prediction, right? And then here, as you can see, running against the serving server, and then here I'm getting some results back, which basically tells me how good this prediction is, and if it's classified as the celebrity I want, right? All right. So anyway, so that's the serving demo.
So in the next step, we are going to use TensorFlow training with Kubeflow to show you this. We have a Kubernetes cluster with GPUs. So you can see NVIDIA.com GPU. So that's pretty much it. And then in the next one, we are going to install Kubeflow. So this is like a older installation, like older version, and it uses the KS. And then now there's like the KFCTL to be able to make this more streamlined. So we are installing all the components here. So at the end, you'll be able to see the Kubeflow components. Like I said, these are the older version of when it was recorded. So there's more stuff now, but this is basically a Kubeflow installation. And then one of the things that the Kubeflow really helps is, like compared to like a Kubernetes batch job, for example, it allows you to just auto-discovery for like things like GPUs. So before you had to specifically specify where the volume mounts is, it's something that a data scientist or even an engineer may not know how it's configured, especially if it's on a managed Kubernetes installation. So with the TF job, it kind of abstracts away all these components, so you don't have to worry about like, hey, where's my driver path, for example. So on the left, you'll see like a very simple bash implementation for Kubernetes for running the same container, and then on the right is the TF job. On this one, so we are basically creating that TF job on Kubernetes. So we do the TF job CRD. So we see the TF job retrain is running, and then we have a persistent volume that's bound now. Skip this a bit. So this is the container that's running. And it will start running, just like Rita showed earlier, so it's very similar to that one, but in this case, it's running on Kubernetes using using Kubeflow. In this case, so we are doing the same thing. As you can see, it's reserving GPUs for this container. Oops. And then so it will also create a TensorBoard instance. So once it will reserve an external IP, and then once we go to the external IP for the TensorBoard, we will be able to see the TensorBoard instance for our training. And then on the next one, we are going to deploy this to ACI.
All right, so the holy grail, right? So now we got our training into Kubernetes, and we're training with TF jobs. Now because of Kubeflow, we have all this stuff running in our cluster, but how do I actually scale that out, right? How do I have one centralized TensorBoard that's looking at all my experiments happening at the same time, and how do I only, like, you know, pay for the container, the resources that I need when they're actually running, right? And so this is where with Virtual Kubelet and ACI, this is where all of them actually work together. So we're gonna first look at the node, and here I'm just showing you, like, that's the Virtual Kubelet. And next, we're actually using Helm to install the hyperparameter experiment, right? And again, an application is an application, right? So you can basically create your application and package it with Helm like any other application. So as you can see here, this actually creates 9 different jobs based on the hyperparameters that I've created, that I've parameterized. And so because there are 9 different permutations, so it creates 9 experiments with 9 TF jobs, right? So as you can see here, all of the jobs actually creates a corresponding pod, and then the pod is they're all running on Virtual Kubelet, as you can see, right? And so what I'm doing right now is I'm doing AZ container list. So just to show you, behind the scenes is actually creating a bunch of container groups on Azure Container Instance. And as you can see, it uses the right SKU that I tell it to. It's using K80, but you can specify whatever SKU you want, right? And as you can see here, this is basically all the information that you give to Azure Container Instance, so it knows what, how to train and how to run your container. And as you can see, it's actually creating these containers right now. Okay, so now the containers are running. Okay, so, and just to show you what it looks like behind the scenes, right? So each pod corresponds to a container group in Azure Container Instance, and as you can see, all of them are running. And here, as you can see, they're utilizing the resources, and then you can actually look at the containers that are actually running. And here's the life cycle of the container, and you can look at all the logs, very much like the logs that you saw earlier, but now we're just inside of Azure, that's all. And then what this is actually doing is it's training all of the your experiments based on the parameters that you specify. So each experiment will have its own test parameters. And then in my Python code, I've also told it to persist the experiment summaries and the models to Azure files, which is like a network share that you can just write all your stuff to. So when we actually load TensorBoard, that's where it's going to retrieve and looking at all the logs and all the summaries. And this is why you're actually seeing all of the test results run at the same time inside of TensorBoard. So you can actually see how each experiment's doing as they're running. I think that's it.
And then all the code and then the examples we talked about are in the first repo from Rita ZH and Kate's -ML. And then also under github.com Azure, we have the Kubeflow labs that kind of takes you through like a workshop kind of concept from how to do it with Docker to Kubernetes to Kubeflow, and then going through like all the components and how you can do this like one example at a time. And then this is how you can create GPU-enabled clusters in Azure using Azure Kubernetes service. And thank you.
So this has all the code and all the YAMLs that you need, all the charts that you need to get all this entire demo to work. And it also has a lot of different videos. I know someone was asking for videos of all of this end-to-end, so check it out. Questions? Oh, also we have stickers, Helm stickers.
When would you choose to use the Azure container interface versus Azure Kubernetes service? It seems like you'd have different types of flexibility with those two approaches.
So it's Azure Container Instance. So when you want to run a cluster, say for your organization, where you want to maintain the lifecycle of your cluster for a long time, that's when you want to actually have the entire cluster, right? And that's when you want to have AKS, so Azure Kubernetes Service. Whereas Azure Container Instance is more like dealing with the container itself. So it's more for people who just want to run their containers, but they might not necessarily want to use anything fancy. So I know someone mentioned like Istio, or like you write your own CRD and you want to deploy it there. Like, so say if I want to deploy Kubeflow, I wouldn't be able to do it on Azure Container Instance, right? Because that itself just runs that workload on its own without knowing anything else around it, right? Whereas with Kubernetes, if you can only run the CRDs and the services and like the Azure, like the PVCs, if you are actually in a cluster itself. Right. So the question is, with Virtual Kubelet, you can actually leverage both, right? And exactly, that's exactly why Virtual Kubelet was created, is so that you can leverage these container runtime providers. And meanwhile, you can still like leverage all the goodies of Kubernetes cluster itself. That way, you can manage it, manage all your applications, deploy it, and manage the lifecycle security with Kubernetes, but you actually only like pay for the resources you need, like when you need it with Virtual Kubelet.
Yeah, so I'm going to say the same thing basically. With Virtual Kubelet, you can burst out to ACI whenever you need to. You don't have to have the necessary like resources in your cluster already. So it's like on demand basically. Yeah, you can like add more nodes to your Kubernetes cluster with like more GPU nodes, but then you'll have to you have to scale down those nodes, which takes more time, and like.
So actually we forgot to talk about cluster autoscaler, right? So cluster autoscaler allows you to scale out your actual nodes in the cluster, right? But don't forget, you still have to manage those nodes once they're created. You have to patch them, you have to love them, right? But with ACI, you don't have to. You just have to schedule them and run them as the container is alive. And then after that, you don't have to ever worry about them, right? But one thing that I also want to mention is persistent volumes, right? So if you have applications where you might not want to persist to a network share, like ACI wouldn't make sense, right? Because it doesn't have this concept of local volume, right? But if you have an application you do care about, like local volume, local persistent PVC, then that's where Kubernetes cluster makes more sense. So it depends. So, but with VK, you can have that best of both worlds.
Along the same lines, as opposed to comparing nodes with Magic Container, what about Magic Container and Magic Function, like Knative? How would you kind of, because you kind of get some of the benefit with like not having to run your own node with the function. Isn't that kind of like a more granular way of doing this?
I can't really comment too much about like Knative. But I can talk about like what I do know, just because I think that the big difference is like running your code as the code itself versus like the life cycle of your container. I think they are kind of different, right? And in this case, you're actually treating your application like a container, not just like, oh, I'm running some Python code or I'm running some, I don't know, Go code or something, right? So I think it's different in that it's more like I guess it's like kind of like Heroku world where you're kind of like a web package, like your build package, right? Whereas now your knowledge and your life cycle is in the container itself. I'm not sure if I'm answering it, but it's a different way of doing the same thing. I think it's just like how much freedom you have with your application, because there's a lot of stuff you can't do with functions and Knative. So I guess it just depends what you need.
Thanks, Rita and Sartak. And next up, we have Pete McKinnon from Red Hat, who's going to talk about how flexible Kubeflow is for deploying and scaling in multiple environments. And specifically in this instance, he's going to talk about taking a local deploy environment and scaling it up to OpenShift. So.
Hello. Welcome to this slightly delayed presentation. I'd like to thank Canonical for sabotaging Red Hat. Thank you, Josh. Very clever. I would like to thank Canonical. They were the drivers behind putting together Kubeflow Day, so it's a great event. Thanks, Josh. Let's see. Let me put this down. Since this presentation is starting so late, it's going to move pretty quickly. And we're going to skip over some stuff. So by now and basically the presentation's talking about specific feature of Kubeflow, which is its capability or ability to be deployed into multiple environments. And we'll look at what that means with respect to different environments. So you've seen lots of slides up to this point, starting with this morning. It should give you this sort of sense that it's actually pretty tricky to put together a machine learning platform when you consider all these different parts, the model training, the management of the data provenance, building the model, rolling that model out into production, a lot of parts involved. So when our heroes at Kubeflow, like Jeremy, started the project, they set out some sort of high-level sort of goals for the project. And that is portability, scalability, and composability. And composability is really covered, in the sense of microservice architecture. But this talk will focus on those first two things, the portability and scalability. So the notion that you can go from the bare metal to the cloud with this machine learning platform, open source platform, and that it scales easily. So starting with a developer and their machine, which is maybe a laptop or something like that, they can scale out to hundreds of nodes. So guess what? Surprise, surprise. Kubernetes is a terrific enabler for this type of these types of goals, right? And today with Kubernetes, we have sort of different dimensions of Kubernetes in respect of there's on-prem in terms of how you deploy it. There's hybrid cloud, which my company is very much involved in. And then there's the public cloud providers, so GKE, EKS, AKS, Azure, EC2, all that stuff. So that's one dimension of the problem, and then the other part is the Kubernetes distributions themselves. So there's OpenShift, which my company, Red Hat, makes. There's Rancher. Docker has an implementation of Kubernetes that you can install on your desktop. So there's a couple of dimensions to this challenge. And when it comes to the cloud providers, you can think of the different ways there is to authenticate to these environments. And then as Kubeflow sort of matures, there's also this notion of how do we sort of take that authentication, ideally a one-time SSO type authentication, and apply that and manage it within the cluster itself. And in this case, I'm talking about a Kubeflow cluster. Then there's considerations with respect to storage, Google storage versus S3, local storage, or block storage like Ceph, NFS. And then there's considerations around the hardware resources, which are very important in machine learning platforms, so particularly with GPUs. There's different types of ways to install GPU capabilities for the different types of Kubernetes providers. Certainly my company with respect to RHEL is very invested in SE Linux. So doing that in that type of environment provides some, or imposes some additional considerations, as it were. But nonetheless, the community project, the open source project, Kubeflow, strives to kind of put all that to rest for the users and the operators. So to make it easy as a user and an operator to have a consistent experience. So by now you have a sense of the components involved. So we sort of have this elastic notion of the core components, what spills out of KF Cuddle. If you do an install of, say, 0.4, there is the Ambassador component for ingress control. Jupyter Hub, we have an asterisk there because that is undergoing an evolution. So in 0.5, There will be some significant changes happening in the notebook launch space. There's KATIB, which has been discussed for hyperparameter tuning, kubeflow pipelines, the training controller, all that stuff. And then you have these various other components. So this span of components also provides various different considerations for how you deploy this into different environments, starting with just a local dev environment and then scaling up into these cloud environments. So when our heroes at Google started, they were looking around in terms of what could provide a capability for config management for this new project. And they settled upon a project called KSNet. So that's a CLI tool that's still used today within kubeflow. And it's used to basically specify and generate these Kubernetes deployment objects. It's based on the JSONet language. And it's more expressive than just using, directly JSON or YAML for defining your Kubernetes components. So you have variables, conditionals, mix-ins. You have the notion of prototypes where you can install various different components from, think of them as libraries that are repos that could be hosted in GitHub. Fairly powerful constructs. And when KSNet generates those resources as they're defined, what you get out of that is entirely compatible with Kubernetes, okay? So those objects that are services, pods, deployments, all these things, you can directly edit those. You can modify those. The idea is that you would have sort of a, if you will, a source of truth for your application. And that would be expressed by this config management that's managed or defined using KSNet. The other part of that was, again, sort of thinking of this multi-environment sort of problem, is that in the enterprise, you would have sort of a staged rollout of a machine learning type offering or implementation. So you might start out in a dev environment with certain specifications or capabilities, test environment, onto staging, prod. The idea with KSNet is that by a minimal specification of a variable or two, that could greatly sort of define and impact how the application is actually generated that is deployed into that specific Kubernetes environment. It also had the ability for continuous deployment, and you could delete these resources by deleting the components themselves. But, sad trombone. What happened at the end of last year is that VMware acquired Heft.io, and Heft.io is a very influential, or was a very influential company in the Kubernetes space. And they made an announcement early in February in a blog post that sort of made some declarations about what they were going to do with some of these open source projects that they'd started. One of those was KSNet, and unfortunately the decision was made that KSNet would be shuttered in terms of new development. So what that has done is pushed our happy kubeflow community to kind of take a step back and think about decisions to make about how do we want to come back to this problem of config management for this application. So the key point here is that even with this announcement about KSNet, there's still an underlying goal of the project, and that hasn't changed, is that it should still be very easy to deploy kubeflow into these different types of environments. That's still a key goal. And also, KSNet provide an on-ramp for the various integrations that were really key to the beginning of the project. Going back a year ago, we had Selden integrate into the project, Pachyderm, and the roadmap for that in terms of the integration was provided via KSNet. So it's still important to have that type of capability. So today the community is evaluating options. There's a lot of interest. I don't know if Cam's here, Jeremy, but there's some interest in Kustomize, which is an open source project for YAML-based type of configuration, similar to what KSNet provided. There's Capitan, there's Helm 2. The folks at Microsoft were just talking about Helm. And and then there's its antecedent, Helm 3. So a couple options. We're actively looking at that and making decisions as a community about that. So still sticking with KSNet, it's not dead yet. It's still used in our community for the time being. But with the creation of this shell script that basically spawned a kubeflow deployment for you, you could basically specify these different types of platform settings. And what would happen is that from that, it would define a set of parameters that would be relevant for what you were doing. So in the case of TF serving, if you're storing your models in S3, there'd be parameters for zone, region, endpoint, whether you wanted to verify SSL, things like that, the access key ID. Docker for desktop and Minikube, two sort of developer type implementations of Kubernetes for that. It'd be a definition for the local storage. Alibaba has been very involved in kubeflow, and they're, the Chinese company. They, one of the early issues with Alibaba is they realized that they couldn't get access to some of the public images that were being curated and produced by the kubeflow community. So that's due to the Great Firewall. So there's parameter changes in there so that it provides a different URL to a mirror inside the Great Firewall for pulling those images. And then GCP, there's the API version for GKE, Zone, Email Project, the endpoint, Google Application Credential Secret, all this information. So these are the types of parameters that's important to capture and have sort of defined to make it easier for an operator to deploy kubeflow into different environments. So I don't know if we've made a decision about Kustomize. It's certainly a front runner, but Kustomize is interesting as an alternative, and it's still sort of this notion of that we would have a common or a base set of definition in YAML, and then those would be processed against specific sort of overlays or overrides of perhaps those base definitions, or there would be enhancements to those definitions for that environment. So Minishift, kind of like Minikube, that's the OpenShift version of Minikube. I'm going to talk about OpenShift in a second. And then you could imagine that there's an overlay of GKE type parameters that would be processed and then used for deployment into Google Cloud. Okay, so that's kind of where the community is at with basically this notion of adopting a new customization or configuration tool. So just a word about OpenShift. That's my company's Kubernetes distribution. It's enterprise Kubernetes distribution. The design of OpenShift is really around enhancing the developer experience for developers using Kubernetes, and also for the operators who are tasked with deployment into the enterprise environments. There's higher levels of security around things like container UIDs, not being able to run a container that lacks a UID, or a container that's trying to bind to port 80 or something like that, and it's still, it's not a well-known UID. So things like that, there's controls within OpenShift for managing that. It's very much self-service. There's developer tools for basically quickly generating applications. And underneath that, it's still all the same Kubernetes constructs that you know and love. So, pod services, it all integrates seamlessly with Kubernetes. So, I don't know if that's going to run. That's supposed to be an animated GIF, but does it run if I do that? It does. Maybe. Doesn't matter. There's a developer tool with OpenShift that is the OpenShift client. As part of that tool, it has a ability to fire up a developer Kubernetes instance. And basically what it does is it pulls down an image and fires up a container, which in itself is a self-contained Kubernetes environment, whereby you can quickly deploy an application. In this case, the application we're interested in deploying is kubeflow itself. This runs in developer environments. I know it's heretical to say this at a Linux conference. This is actually running on my MacBook Pro, or that's where the video was stolen from. So that's a 16 gig environment. It's limited, but it can be useful for doing quick sort of evaluations of various Kubernetes type applications, most notably kubeflow. And then there's the deployment of kubeflow itself. So on our website with the getting started information, there's a fairly well laid out sort of recipe that involves the kfctl shell script for deploying into basically a bare metal or on-premise environment. So that's what you're looking at here. Again, this is in a local developer environment. It's running in this OC cluster up environment. And it's the same instructions that you would follow basically anywhere to deploy kubeflow, generally. So to run kubeflow on OpenShift, this enterprise Kubernetes distribution, there's some considerations because of the extended resource concepts and the RBAC stuff. There's these enhancements around things like namespaces of projects, and there's permissions and constraints that are applied to the security context around those things. So we at Red Hat have had a lot of success with OpenShift, and it's been a popular Kubernetes distribution. The kubeflow community does most of its development using a general form of Kubernetes, and a lot of the development is done in GCP and GKE. So the other thing that's come on recently, not just in kubeflow, but in the Kubernetes space, is development of operators. So kubeflow has developed its own set of operators, and the ecosystem that we're integrating with is also making a strong use of these operators. And operators typically consist of an implementation, maybe in Golang, of some type of capability that is managing a very specific application resource for you. Then in the Kubernetes, in terms of the resource sense, there's custom resource definitions, cluster rules, and cluster rule bindings. So these all have to, a CRD, as you know, has to be installed as a cluster admin. But these can prevent or, impose challenges in terms of deploying kubeflow onto OpenShift. So there's sort of I create an issue up on the community and captured a friction log there. And there's various sets of sort of cluster admin type capabilities that you have to apply to some of the components to get it running smoothly on OpenShift. But having done all that, let's look at just a little demo, and it's not a live demo. It is, let's see, where are we? Yes, slides. And so that same application of kubeflow that you saw earlier in the other video there, this is the exact same deployment, and that's really the point I'm trying to make here with kubeflow, that this one has been deployed into a much more robust environment. That environment is running RHEL 7.6. It has 64 gig of RAM, 8 CPU, but more importantly, it has an NVIDIA V100 GPU. So this is playing in a loop, but what it's showing you is that using the same components that are specified from kfctl, I can basically launch a Jupyter Hub instance, specify one of the curated GPU TensorFlow images from the kubeflow project and have it run successfully in this environment. I'll say it again, it's all the same code. Whether I installed it in my MacBook or installed it in this larger environment that just so happens to have a very expensive GPU card in it. So that's the beauty of a kubeflow. It's something that the community really strives for in terms of a project goal, that this is a very portable type of environment, especially with people who are just getting started with machine learning platforms, that they can work comfortably and easily sort of in a local environment and then take that out to be their bigger game in these larger environments with more capabilities. So back to this guy, and so it brings us to, and you've heard this before from other people in the community, we love getting feedback. And in the context of this particular presentation, what we love hearing about is any issues or challenges that you encounter trying to use kubeflow or deploy it into different types of environments. We'd like to try and have all-encompassing experience for kubeflow in many different types of environments, whether it's on-prem, bare metal, certain cloud environments. So what helps us is providing us with your support in the way of testing, GitHub issues, friction logs, pull requests if you've found something that needs to be fixed. Love to hear about it. When you generate a GitHub issue, it'd be great to have specific details. So, for example, you had a notebook pod that didn't launch and you discovered it was because of this, and then you need to do something to get it running in a particular cloud environment. Tell us about that. Capture the information, the logs, the config in GIS, redact it if you have to, and throw it over to us, and let the community have at it in terms of making it a better, smoother kubeflow experience for everyone. So, and that's the abbreviated version of my talk, I think. Any questions? No? We good? Thank you.
Thanks, Pete. Up next, we have my coworker, actually, Fatih Nar, who's new to Kubeflow, but is going to talk about it in the context of AI use cases he's seeing in the field as a customer engineer at Google.
afternoon. Good afternoon. So I have some stickers, each unique. From the friends from Japan, Studio Ghibli, if you're familiar with their work. Each unique, and you will not see them ever again other than your laptop. But these are like 5 of them. In order to get it, you have to answer questions. So I need some interaction in here first. All right. As my friend introduced, I'm new to the Kubeflow. However, I am not new to the Kubernetes nor the MLAI. So before I joined Google, I was part of Verizon Wireless as a distinguished member. Before that, I was in Canonical Ubuntu. I did my serving to the SAE, whatever you call him now, self-appointed dictator for life. And then before that, it was Ericsson. So through my life, I have worked in different disciplines of technology, including voice over IP, IPTV, media backends, infrastructure as a service, platform as a service, software as a service. Now in Google, helping you, developers and customers and enterprises, to bring the workloads to the cloud. It's easy to say, but it's kind of hard to do it, isn't it? Especially if you're in love with the technology, but your counterpart on the business side is not seeing the light at the end of the tunnel as a return of investment, it's kind of a challenging situation. So let me stop there. And what's the picture about is, this is my personal car. I got a big accident last weekend in Dallas. I got T-boned literally, and it was unfortunately my mistake. And I wasn't on my phone or anything. It was just 1 second, I guess, distraction. I got T-boned. And the funny thing is, before I left Verizon, we were working on an edge computing cases, and one of them was literally the red light detection and stop light detection. And we did it. We did it, and we deployed some 5G sites, and our deployment is still running on top of Kubernetes. And that Kubernetes deployment, the basic quality is redeployable without creating snowflakes iteratively, so we can scale and bring workloads on top of it as much as we can without changing the workloads. But at the time, it wasn't possible. Now with the Kubeflow, especially for MLAI, it's possible. So other than this case, what I'm going to present you today is go over, you saw this chart a little bit different perspective, is I'd like to talk more about the use cases that you can go and advocate inside your organizations to get some funding. Because at the end of the day, your job is tied with the business. This is the reality. If you can bring a good use case for your MLAI, which is really hard, especially if you're doing unsupervised learning, you don't know what you're going to get out of the unsupervised training, especially clustering, which I will give you a couple of good examples from the field. You may not get good sponsors. All right. Has anybody heard 2 words in the same sentence? Walmart and Pop-Tart. Anybody? Walmart and Pop-Tart. Okay. So obviously we didn't see the news about it 2 years ago. So Walmart has crunched big data, a lot of big data in the last 15 years of purchasing. And they did run the K-mean clustering. And the result came interesting that at the particular times of the year where there's extreme weather conditions, people are buying a lot of flashlights and also Pop-Tarts, right? At first it didn't make sense. Then they realized the human behavior to survive is have a light, blanket, and some comfort food. So that drives the different shelving strategy in Walmarts if the predicted weather is pointing extreme conditions. So when you go in a rainy or stormy or hurricane season in a particular Walmart area, you will notice when you walk in the store, blankets, flashlights, and Pop-Tarts. So this didn't come as a predicted output. They crunched big data with the Terraform and Teradata guys, and it took a while. They spent a lot of money to learn that Pop-Tart sells good in bad weather. So they could do better if they had the Kubeflow at the time and also transferable pipelines that in the sense of they can run anytime, anywhere without restructuring it. So the way we distribute, go ahead. Okay, is this better? All right, sorry. Oh my. Is this better? All right, better? All right, sorry. All right, the microphone's always the problem thing in the conferences. All right. One key challenge, as everybody mentioned, is if you're a data scientist or an ML AI engineer, knowing all these has been the prerequisite, right? You need to know how to package your software, how to distribute your software, how to build your infrastructure such as Kubernetes cluster and maintain it and scale it, and also deploy the stuff on top of it at the same time. It's a lot of work. That's true, yeah. And besides, if you're looking into more accelerated workload cases where you leverage GPUs or TPUs, it needs more expertise as well. So what we did in my previous lives, at that time OpenStack was popular before the Kubernetes stole the title. So the accelerated network applications required better throughput by means of latency and bandwidth, and then the industry invented SRIOV that required different talent on the hardware specification side, designing and drivers, and also workload migration. It has been a lot of challenge. So what it did is mainly it killed the sense of moving workloads on the fly, even though if your infrastructure are failing or you're scaling your workload. So what does Kubernetes do for you? Much more than OpenStack, not only giving you a place to run your application, but also taking care of your life cycle of your application by means of replica sets, or you can use daemons or jobs, as well as monitoring the health as a socket or as a whatever port you like to scan or you want to run as a job to see if my application is healthy. On top of these abilities, we are putting, as many of the folks mentioned, Kubeflow to give you better a tool set to be more productive. So edge use cases. Everybody talking about the 5G, everybody talking about the mobile edge computing, low latency computing. The low latency is only possible in the sense of law of physics if you're close to the place where the event is happening, right? That is only possible if your execution environment for your application is close to that event place. So in the sense of telecommunication, everybody saying that, okay, we'll put some edge computing nodes where the E-node Bs, which is the radio stations, are located. That's what Verizon and AT&T has been doing with partnering with other telco vendors. But what they are not thinking yet is mainly, okay, the investment I'm doing on those edge, I'm putting a couple of servers, but they're not thinking a step further. How I'm gonna put an infrastructure that can be reused by others without requiring a lot of administration. So they first thought about using OpenStack, then realized OpenStack is not really a way to go for portable workloads. And then they start looking at more on the Kubernetes. And then OpenStack Foundation changed its name to be more agile and close to the Kubernetes. So at the end of the day, what you're hearing from other organizations under the Linux Foundation is mainly what you're seeing here is the base infrastructure is depending on Kubernetes. So you saw on the other presentations that you can do your ML AI app packaging on your developer laptop or a workstation, and then push it to a cloud for heavy lifting, for training the algorithm. Because what makes sense is train your algorithm with a bigger data set, merge data sets. So one reality we saw in the field is to have a better insights that is valuable for your business or your partners, you have to crunch a lot of data, a lot of different data. So if you think I have a 1 petabyte data and I'll have a great insights coming out of it, may not be happening. You have to think differently, combine different data sets. You have a data set for weather forecast, combine with the sales from nearby retail stores. If you're not in the sales, only predicting which areas in the neighborhood will gonna be more popular for house sales, combined with the geographic topology information. And you may say, okay, I don't have those data, right? That's the reality, and Josh is sleeping right there. Sorry. Reality is, you don't have any excuse. Right now, all the political situations in the world is driving data to be opened by governments as well as organizations. If you need a certain set of type of data, there are already data brokers out there, they are selling data. If your organization doesn't know what to do with the data you have, you can consider selling your data through a broker and be a partner, whoever using it, as a kickback for a business. So there are different businesses right now running in the world for big data, ML, and AI. You don't have to necessarily know that this data will be used for this particular business. Maybe it may be. Or if you combine with other data you can purchase from a data broker, gather more different insights. So one of the use cases we saw in the field we partner is one of the retailers, which is very famous, one of the Sears and JCPenney, you pick the name. They put a carpet that pretty much senses the footsteps, the size of the footsteps, time and recording, and they saw that in the particular timeline of the week and particular time of the day, there are different shopping behaviors. After 6 p.m., they noticed that the families with the little kids running fast through the store to obviously the toy section, and in the other time of the day, especially lunchtime, the women behavioral is different than men by means of going which department and purchase something. So they crunch the data and they come up with that, okay, how can we restructure our store dynamically and fast that we can get more business out of, driven by the data. So today one of the key conversations about, all right, it's good to talk about, running the workloads at the edge, but edge is not ready. It's true and not true. And the one example was given was the Raspberry Pi. Obviously, Raspberry Pi doesn't have enough muscle power to run the inference or prediction at the edge. But now, Google has announced the edge TPU last year. Now it's available for purchase, and this is a purchase set that you can go buy around $149. And you can see the test benchmarks. The leftmost column showing that basically the development board with the edge TPU versus the desktop CPU with the 8-core, which is an expensive combination, plus USB accelerator. If you see the numbers, it's pretty much the same, meaning that once you have a accelerated board like this with the edge TPU plugged either to your Arduino or a Raspberry Pi, it's good enough to run your inference at the edge that you trained the algorithm obviously before to provide you low latency predictions. And one of the examples could be easily plug a small Raspberry Pi size computer in your car with a small damn camera to give you a buzz. Dude, you're going so fast and there's a red light right there. It's not a future, it's right today, it's doable. And this hardware is already available for your purchase and consumption to deliver such use cases. All right. So one of the things I have learned through my life is community is better than the companies. This is true. Companies has their own focus for business, has their own agenda, despite they are leveraging the same technology, but the community has higher purposes. The reason OpenStack grow a lot because of the contribution from the larger community. And hopefully Kubeflow will grow as fast, as big as possible to deliver ready-to-use pipelines. Even more than that, ready-to-use as a base pipelines that you can put additional components on top to deliver different experiences. All right, another question. Another question. Today, when you deploy a Kubernetes, I know this is kind of a DevOps question, sorry for that. We have masters and workers, right? Master nodes and worker nodes. Before we called them workers, we used to call them something else. No. Minions. The sticker for you here, right? If you like to get it. Perfect. It was kind of a historical question, but all right. Another question. Another question. Another question. When you deploy a new additional feature on top of Kubernetes, such as Istio, it's not necessarily a regular pod, but it's something else we call. What do we call, for example, Envoy or Istio on a worker node? Yes, sidecar. There's a sticker here for you if you want to get it too. All right. So the reason I'm asking these silly questions is mainly Kubernetes is open to different way of delivering different feature sets. It could be daemons, it could be sidecars, it could be pods. And Kubeflow is leveraging that heritage. All right. So your business may need you to deliver something brand new, or your business or your partner in the crime needs something that's already out there to use as an API. For example, Google Cloud has a Vision API. You can use Vision API to detect objects and label them. You can use Speech API to mainly from speech to text, text to speech conversion. Or if you need something a little bit different, you can train your algorithm on the ML engine and export it. If you want to do something definitely brand new on the edge by means of either training or just running inference or a prediction, where you're going to see the benefit of Kubeflow. It's not necessarily these are all separate worlds. It's maybe you can combine them in a sense that get best price performance for your spending and what you're getting out of it. Crunch the data, train your algorithm on ML engine, leverage the TPUs, leverage the preemptible VMs with the minimum bucks, export it and run your edge with the Raspberry Pi with the HTTP accelerator. Much, much less than what you will spend buying server with GPUs, maintaining them, electricity, cooling, even securing those servers. All right. This is just in a self-advertisement, just skipping it. Which many folks talked about these already. And pipelines. What I'm going to talk a little bit fast forward is there was a question today, I think it was you, sir, right? About the examples. Right? Yeah. Let's go down there. All right. Back a little bit. Here we go. So the demo that I'm going to talk about is mainly from the Kubeflow GitHub under examples. So I took a little bit one step further to give you more easy to grasp and deploy by yourself. I know the projector resolution is not good, but let me tell you what you will be seeing shortly. First, we're going to package our application on our laptop or inside the machine that you are using as a jump host. Mainly what we are doing is building a Docker container, okay? Inside the Docker container, we have a machine learning algorithm. Then we're going to push that container to the Google Cloud Container Repository, GCR. And then at the same time, we will deploy a small Kubeflow cluster, which you will see very easy to do through even UI or CLI. And then we're going to train the algorithm on the Google Kubernetes Engine GKE-based Kubeflow cluster. Once the training done, we're going to export the model into our object storage, Google Cloud Storage. And then, imagine this is running at the edge, this cluster, Kubeflow cluster running at the edge. We will simply push that model from GCS into the edge infrastructure where the Kubeflow is running, all right? And then we're going to run the prediction in here. As a sample output, we will deploy one web app frontend to kind of run sample inference test cases. So the first step is mainly deploying your Kubeflow. If you go to deploy.kubeflow.cloud, you will see a UI like this, and on the left of it, you will see put your project ID and deployment name. Project ID is the project that you created on Google Cloud Platform. So the first precondition is go with your Gmail address, log into the Google Cloud Console. If this is your first time logging in, you'll see you are given a $300 of credit, which is good enough if you ask me, and I experienced that through when I wasn't part of the Google, good enough for a sample ML, AI, or even big data analysis workload. So what I did before I joined Google, I collected the weather forecast from the Open Data Initiative in Dallas, as well as the ground humidity for agriculture. I pushed it into BigQuery. From BigQuery, I did run mainly ML AI. And that cost me around $100, believe it or not, and that data set was around 100 terabytes. So once you created your project, put the name in there. What it will do is mainly, let me take this out of the presentation mode. This is the site. Let's create another Kubeflow clusters as a sample in here. All right, my project name. All right. My project name is, you can see it in the home button in here. Get the project ID is Kubeflow Demo 2019. Kubeflow LA. How about that? And click on it. Let's go back and look at our deployment status. It's coming up. I hope I have internet in here, right? So what it will do is, it will go create a deployment set first. And show your deployment in here. As you see, Kubeflow LA is getting deployed. So there are different types of tools that you will see out there from AWS, Azure, and us, and also on top of their other umbrella solutions such as Terraform and so on and so forth. We have our own automated way of deploying things. We call it cloud deployment model. So what that UI triggered is automated way of deploying a cluster, where right now it's running. It will trigger first creation of the virtual machines, and on top of the virtual machines, we'll deploy the Kubernetes. And on top of the Kubernetes, we'll install automatically the Kubeflow. That's the first step. And it's only one click through a UI. So you may say, I will not remember that. I'll go to my presentation. Here we go. All the references in here. So if I go and open you this GitHub repo quick, which is this page. This page is literally, I put down all the steps that we are running through with all the details. Even though the code is literally under the Kubeflow example for optical character recognition through MLAI, all the steps described in here with the CLI commands and everything. If you see an error, feel free to drop me a message so I can convert it. And if there wants, I can add this README as a second README under the examples if you want. Good. All right. Come on. All right. All right. So after the cluster is deployed, obviously you can go and do the get the details of the cluster for the Kubeflow namespace. So kubectl get pods -- namespace equals Kubeflow. Here we go. So these are the pods that are deployed automatically under the Kubeflow namespace that are delivering the Kubeflow components in here, right? So the following step, okay, our Kubeflow is up and running. We packaged our Docker through the steps I have provided. Next step is running the ML training and then exporting into GCS bucket. All right. Who has here never touched Docker before? All right, so everybody knows how to build a container out of a manifest, I assume, right? It's pretty straightforward. Who has recently pushed a container into a Docker repo or GCR? All right. So the question here is, imagine your partner in crime says that, hey, this is our idea, we cannot put on a public repo, right? Man, you cannot push your container in a public repo. They will steal it, they will download it. So what would you do? So the answer could be either, hey, I'll get a managed service from Docker or GCR for a private repo, right? Or set up your own, exactly. It's not rocket science, is it? But the problem with setting your own is coming with your responsibility. What if that machine crashes? What if you have a hard disk failure? You lost the container, right? So that's where the managed service comes with the beauty of, hey, they provide you SLA by means of service level agreement. Whatever container you push out there, even if it's a private repo, it will be there. Since you're paying for it, even the backend crashes, there's a replication come into a picture that will help you continue your business. Plus, delivery. So when you push a container into a GCR, you can pull it from the edge computing sites with the much better throughput and latency than those edge sites connecting to your headquarters. God forbid if you're using a VPN for remote connectivity and so on and so forth. That's another bottleneck. All right. So in the previous Red Hat presentation, our friend mentioned, and in this demo, we are also using Casonet as well mainly for configuration management to leverage Casonet for different contextual switches. All right. So what you see here is mainly is where we build the first container and then, as you'll see, pushing into the path we are given above, which is the GCR path. And then training based on the G-key cluster that we just deployed as a Kubeflow cluster. And Cassandra is mainly giving where to download the container and running on top of mainly the Kubernetes cluster. And the last step is step number 8, where Kubeflow running as the edge, at the edge side where predictions is happening. Again, the same path used for GCRIO for downloading the container and applying the config model through Cassandra, and then running the inference. Obviously, when you run a predictions at the edge, easy way to see a demo purpose is to build a web front end, which we did in here. Let me show you. Go to our, all right. Kubeflow service. This is the web UI that's running as a Docker container on the same edge Kubeflow Kubernetes cluster, and this is the UI IP address. If I go down there and see, this side is connecting to the prediction or inference serving right now on top of Kubeflow and giving you an image that will translate into a character. This one says it's most likely number 1, I guess. Let's try this again. It says 6, and so on and so forth. So in this demo, we leverage the existing data set from MNest and use a ML algorithm inside a Docker container, push to the GCR, downloaded for machine learning training purpose on Kubeflow, exported the trained algorithm into Google storage bucket, and then pull it into, again, Kubeflow for inference. So that's the long story short that I will give you today. Any questions so far? Did I make you sleep worse than before? Sure. Which step? Oh, okay, sure. For this example, let me open the code. Yeah, sure. So first, let me take that question so I can show the code quickly. So the good thing, the beautiful thing about the GCP, you can directly use your source repo on there. The source repositories in here, as well as your container registry. And code is in, I just sync with my GitHub in here, right? If I go MNest example in here, this is the model in here. I'm not sure if you can see it. This is the model that we package inside the Docker, and then we run the training on top of it. Can you see it? Okay. So this repo, so Google Cloud repository is per project base. You can sync with your GitHub 2 ways, and also do the code changes in here, automatically trigger your CI/CD pipeline, building the container on the fly, and also deploying through Spinnaker. So back to the other question, going back to which step you said, I'm sorry? Oh, URL follow lab. Oh, okay. All right. I hope this made a little bit of sense. by means of not only using the tools for the sake of using it, but generating something valuable for an idea becoming a reality, and reality becoming a business income for you. As I said, at the end of the day, technology comes and goes. The main thing is what you're getting out of it as an output. Today, as you saw, Cassandra is, no longer will be the obvious choice for us because of the acquisition of Haptio. Something else will be replacing it. And later we'll see other tools and come in and go. And mainly, if you have an idea, if these tools are making your life easier, use it. If you need a support, leverage the community. That's the only message I can give you as an experience. Community is a two-way road, by the way. You will not only sucking knowledge and data out of it. You need to think that, hey, I'm part of a family. I have to contribute back. Because I see in my experience that some organizations out there, I don't want to name those service providers, getting open source projects, bundling as a business proposal, but not delivering anything back to community. This is not the way. This is so selfish. Don't do it. Contribute back, please. This is how we grow as a knowledge, as a human organization. All right, that's it. And stickers are here for the people who like Totoro. Come on and take it if you want. I'll give you one. How about that?
All right, next up we have a workshop on using model-driven architecture to deploy Kubeflow at scale from Kenneth Koski, who works at Canonical. Kenneth, are you here? Yes, excellent.
As an implementation of Kubernetes persistent volumes. This is the end-to-end story. So this is what we do, planet-scale data management. We can snapshot and version and package and distribute in a peer-to-peer network your data. So you can be working locally. You can be producing versions of your data. You put things in a file system. You snapshot it in a notebook. And then you start machine learning pipelines from this snapshot. This is what we'll demo today. And then you distribute these versions elsewhere. So this is a pipeline. You've heard lots about pipelines today, right? Pipelines are big in the machine learning space. And Kubeflow gives you a standard way of running your pipelines, Kubeflow pipelines. Instead of having these pipelines access a data lake directly, you have them access us as your data management layer. You have them access a local disk, a local directory /data that we manage and that we can then snapshot and clone for your steps. So each step of your pipeline works on a different clone of the data, and you can have full reproducibility of how your pipeline runs. For each step of the pipeline, you can essentially go in and say, what did this step start from, and what did this step produce? And then you can mount all of this in a notebook and start over. This is the idea, that you use notebooks to experiment. You store your data in persistent volumes. You create pipelines from these persistent volumes, and then you can continue experimenting and iterating. So this is too much talk, but let's see what this has been doing. So vagrant up, okay, it came up, inserted a new SSH key, welcome to mini kubeflow, run vagrant SSH to get started. Okay, I'll do that. So at this point, this is a full kubeflow deployment on Kubernetes. So this is Kubernetes, and you can use all Kubernetes commands to manage it, to interact with it. Okay, welcome to mini kubeflow, type mini kubeflow to ensure everything is up and running. This is our provisioning script. So you run our provisioning script. Okay. Welcome to our provisioning script. So mini kubeflow is minikube, a small deployment of Kubernetes, kubeflow, and Rock, our software for data management. Okay. Yes. You accept our end user license agreement. So at this point, the script essentially declares what you need to be running and ensures it's created by the pipeline into a new notebook. So I'll be using a notebook to explore what happened. So again, I spawn the notebook, but this time it's going to be seeded with data. Again, I can go back into mini kubeflow and see that my pod is being created. Okay, I can actually watch for this operation. And this was just shortcut for this, right? Okay, it's running. It became running in like 29 seconds. Jupyter Hub is not very clever in detecting when the pod is up, so I can just refresh instead of giving it more time. So my notebook is up, my snapshot is here, and it already has files in it. It contains the state of the pipeline step, exactly as it was. So step 2 was expected. Let me increase the font so you can actually see it. So step 2 was expected to run. At this state, I have all 3 files. I have the gzipped file that step 1 created, and I have the unzipped file that step 2 created. So I can actually see what happened. So I can have full introspection using notebooks in the results of my pipeline. This is it. And then, why is this important? Because I can split pipelines and run them in a hybrid fashion across locations, or I can recreate pipelines that were interesting and produced exciting results. And why do we want to do that? So you can have development, training, and deployment happening in distinct locations, being driven by distinct people using distinct platforms. So you're running mini kubeflow on your laptops, exactly as we did now. You're deploying over your local, you're developing and deploying over your local disk using the exact same APIs. We used pipelines, we used notebooks, we can use Katib locally. We don't have to go to another location to do that. And then when we want to train at scale, we can move to the Google Cloud, for example, and get 2 or 3 GPU-enabled instances. And when we're done, we can snapshot the results of our training, the model, and distribute it to our fleet of self-driving cars, which will be running inference at scale. And all of this happens with Kubernetes and kubeflow running on each individual location. And we don't have to change our code. But we have repeated it like 20 times today, so this has become more or less common knowledge. This is it. And the way we work is we appear as a CSI plugin under Kubernetes, and we make kubeflow data aware by contributing code to have all kubeflow components access persistent volumes. Okay, I'll skip the technical part. If you want, we can go over them, but the discussion may be a bit too technical. Thank you. We have a mini Kubeflow channel in Kubeflow Slack. Please download mini Kubeflow, try it out, let us know how it goes, let us know if there's friction, if there's anything that you feel could be improved, if you have suggestions. We're really looking forward to your suggestions and contributions. Thank you.
Any questions you may have?
I've got this very nice microphone here. Josh, anything else?
Thank you, Evangelist. That's super awesome. That was very exciting to have launched something today. So thanks all of you for coming, and thank you for the people who have stayed until like the bitter end here. We really appreciate your enthusiasm. And so I guess the takeaway here, we've seen so many talks about different use cases for Kubeflow, but the key is we would like you to try it. We would like you to send us your friction logs and your bugs. We would like you to try all the different integrations that exist in the community to work with your cloud provider or your data, your machine learning workflow. Sorry, it's getting to be that time. And one last thing that would be super helpful for us, just to figure out what kinds of content would be most useful for us to bring to community conferences like this in the future, would be to respond to an attendee survey that Josh just put together on the fly for you all. So if you could visit the link, I think that Elon will also distribute it via email to all the people who have registered for this particular summit. But yes, let us know what you think. We're all ears. Thanks for coming. In case you were wondering, we finished up early today. So I think one of the workshops became much shorter than expected. But I don't think we've had many breaks today, so I for one am not sorry.
If you guys are expecting the session at 5, we did it at 4:30, and it's already done. You're more than welcome to stay. But yeah, the guys are here. If you have questions, just in the second row here. Otherwise, that demo has already been done.
Can you hear me? Okay. So thanks for your interest in watching this demo. But I have to undo the results of the previous demo, so you'll give me 2 seconds. Nope. So it's all real because some of the steps fail, right? That's proof. Okay. And let me okay, and we have destroyed everything. Okay, so this is where we start from. This is a presentation on Mini Kubeflow. Mini Kubeflow is a product that we announced today, essentially a packaged version of Kubeflow, so that you can run it on your local machine and get onboarded and be able to use Kubeflow as fast as you can. So, are you familiar with what Kubeflow is? Yes, you're on Kubeflow Day. But if not, Kubeflow is a way to containerize ML components for Kubernetes. I'll be talking more about this later on because, this can take like 5 or 10 minutes, which is very short. So the fastest and easiest way to run Kubeflow. Okay. What's the story? The story is run these 2 commands, wait for a few minutes, and be done. So this is what I'll demo today. So to get Kubeflow up and running, you go into a command prompt, you create a directory, you switch into this directory, you use Vagrant, which is a tool to manage virtual machines to initialize it based on a box that we produce. We call it mini kubeflow. Okay, and then you ask Vagrant to bring up the machine. This is it. So at this point, I've already downloaded the about 8 gigabytes that this box requires, because kubeflow is a lot of code. Vagrant is extracting this code, and then we'll run a short provisioning script so you can try it out. So are you familiar with Minikube, for example? Minikube is a very easy way to run Kubernetes on your local machine and start experimenting with Kubernetes APIs. Why is this important? Because you can have a full Kubernetes deployment and you can use the exact same APIs. You can deploy your workloads in the exact same way you would on the cloud. So mini kubeflow is Minikube plus kubeflow on this Minikube plus Rock, Arictos, our own data management software. So you have a full deployment of kubeflow on Kubernetes with our data management software that you can use locally in a few minutes. And this is now uploaded to the internet, and you can go and try it out right now. I mean, don't do it right now, because A, I'd like you to be paying attention to me, and B, the network here may not be as fast to download 8 gigabytes of data. So this is progressing, and it's copying lots of stuff on my disk. So I'll switch to the presentation and talk a bit more about kubeflow. So what is kubeflow? This is a figure from Google's TFX paper. TFX is Google's internal machine learning infrastructure. So Google is essentially open sourcing all of these components. To build a machine learning pipeline, you need lots of components that have to do with how you manage your the different steps of building ML models. Okay, all of these components have been containerized and have been open sourced, and kubeflow is containerizing these components so they run as components on Kubernetes. So kubeflow is a project to run machine learning workflows on Kubernetes. So this part of TFX is essentially the focus of kubeflow. Okay, and then you need an orchestration and configuration framework, and kubeflow uses Kubernetes for this. So kubeflow orchestrates these components as pods on Kubernetes. Okay, and then kubeflow provides an integrated front end, a user interface, so you can manage these components. And this is what we are contributing to kubeflow, a user interface to manage notebooks. Most data scientists begin with notebooks. So we are contributing code to kubeflow to manage notebooks easily and efficiently. And then there's these two big white boxes at the bottom that are garbage collection, data access controls, and pipeline storage. So where do you store your data? And this is what our software brings. So when people talk about ML pipelines, they omit the most important part. How do you handle your data? And you can always go to an external data lake to be fetching your data and uploading it back to the data lake, but this is not efficient. This doesn't work if you want reproducibility, if you want performance, if you want to work in a hybrid fashion. So we combine kubeflow, our improvements to kubeflow's user interface, which we contribute as open source to kubeflow. We are core of kubeflow contributors. And our software for data management into a whole. And this is what mini kubeflow is for a local deployment. Okay? So what can you do then? Our business is planet scale data management. We allow you to take your data, a local file system that you have mounted on your pods that you are manipulating from within your notebook, and we allow you to snapshot it, take multiple points in time snapshots, one every 5 minutes, for example. We allow you to version these snapshots and package them. This is similar to what Git does for your code. We are essentially a Git for your data. And then we can distribute these snapshots. And you can share these snapshots with colleagues, in a completely decentralized way over a peer-to-peer network. If 10 developers are sitting here and producing data snapshots, they exchange these snapshots in a secure way over local links. You don't have to upload something to the cloud to bring it back. Make sense? So, before I move on, let's see what Mini Kubeflow is doing. It's done. Okay, and we started like 3 minutes ago. Okay, run Vagrant SSH to get started. Great. Let me move to the top of the screen. Okay. And then there was a welcome message that I cleared that said, run the minikf command. Okay, I'll run it. And this is essentially our provisioning script, which will make sure that everything is up and running so I can start using Kubeflow within minutes. Okay, I'll run the provisioning script. I'll accept the end user license agreement. I'm a very fast reader, actually. And now the provisioning script runs and ensures everything is up and running. So the provisioning script will deploy Minikube, will deploy Docker, will deploy all of the different Kubeflow components, will make sure they are up and running, and eventually it will make sure our software is up and running. And then we can demo using the full set of Kubeflow APIs over this local deployment. So let's give it some more time. It accesses the network to make sure there are no new versions, and the network here is not super good, so there might be a bit of a latency. This happened in the first demo as well. And this is all live, right? It's happening right now. So what you're seeing is actually what's going on right now. And because we don't like silent periods, I'll switch here and show you how I can log into Mini Kubeflow and essentially use it as a local Kubeflow, Kubernetes deployment. It's still running. Okay. Is the network working? Yes, it is. So let's give it some more time. What is it doing? It's updating stuff. Okay, why is it updating stuff? Because it's deploying Docker. Okay. Our apt-get update seems to be not progressing, and I'll blame the network for this, but anyway. See, I can always blame the network and it works. I didn't do anything, I just gave it some more time. And then we're provisioning Minikube, and then we're making sure Kubernetes is up and running, and I can actually use this as a Kubernetes deployment. So I can go and say, tell me what pods are up and running right now. These are the pods that are up and running. And the software is initializing itself as Kubernetes components. But you don't need to know this to run this. You can just be sitting here and watching the provisioning script run. And what the provisioning script does is it makes sure that all of the distinct components are in place before it says, okay, you can use this. So it makes sure to pre-download a notebook image that you can use to spin up your notebooks quickly. It makes sure to ensure all the components are up and running. And when they're up and running, and it's been like, what, 5 minutes after the machine came up? So within 10 minutes total, you can have your own Kubeflow running locally. So let's give it some more time and talk about what we'll be demoing after that. This is a machine learning pipeline. It's 3 steps, for example. At each step, you want to be fetching some data, manipulating it, and then producing data for the next step. So if you use a data lake, a big S3 deployment somewhere, what most people do is they download from this lake, because they need the data to be local, otherwise performance is super bad, sorry. And then they upload the data back to the data lake. So your performance depends on where your data is, and this brings your computation close to your data. You cannot be running somewhere and having your data somewhere else. This will be super slow. Using our approach allows you to essentially use us as the local data management layer. Each step uses a local disk to manipulate data, and we snapshot the disks after each step. We give you APIs in the pipeline to manipulate this. So you can have a snapshot of whatever each step produced. And this allows you the pipeline to be traceable and reproducible. What's the biggest problem in running a machine learning pipeline or any automated pipeline in general? If something doesn't do what you expect it to do, there's no way to actually go inside the step and see what happened, what it did. So what we allow you to do is, oh, this step failed. Okay, this is where it started from. This is the output it produced. I already know its code because I have committed the code for the pipeline in Git. So let me retrace each step exactly. This is what you can do if you run our software. That's our end goal. So what is our end goal with Kubeflow? It's having an end-to-end story that starts from multi-user notebooks, multiple users working on the same Kubeflow deployment, each spinning up their own notebooks, sharing their data, spinning up pipelines from within their notebooks, and then creating new notebooks to explore pipeline steps. So what could this final result of the pipeline be? A model, a trained model. So then you can have a serving pipeline that starts from this model and serves. So why is this important? Because you can have a training pipeline here, producing the trained model here as a snapshot, and then you can have a serving pipeline running somewhere else that starts from the trained model as an input to serve. So you can split a full pipeline in individual steps that run in different locations, because you can very efficiently get output from one step running as input for another step. And you can also recreate the pipeline, because if you can recreate its input and its code, you can recreate it fully. So let's get back to this. It's up and running. How much time passed? 10, 15 minutes at most. Okay. So I'll go here. I'll go to the URL, and this is Kubeflow. You deployed Kubeflow, and you have it up and running locally. So you can go explore Kubeflow APIs right now. So I'll do just that. I'll create a notebook, create a pipeline, then create a notebook again to explore one step in the pipeline. So I'll create a notebook. This is the pipelines component of Kubeflow. This is the notebook components. This is release 0.4. We have contributed a new user interface for release 0.5. Okay, I log in. I'm creating a new notebook from this image. This notebook will have this much CPU and this much memory, and it will have a new volume as my workspace. This is where I'll be storing my Python libraries, for example. And I'll create a data volume that I will mount under pipeline data 2, and it's going to be 1 gigabyte in size. And this is where I'll leave my data as I work in the notebook, so then I can start a pipeline from this data. So I spawn the notebook. At this point, Kubeflow contacts Kubernetes and asks it to create a new pod that will be used as my notebook server. So I can go back to mini Kubeflow and query the pods and see that my container is being created, 19 seconds into being created, 25 seconds, running within 27 seconds. So it took me 30 seconds to get my container, my notebook up and running. I go back here. Jupyter Hub hasn't actually realized the pod is up and running, so I'll just refresh. The new user interface polls more frequently, so it comes up even faster. My notebook is up and running. So you deployed Kubeflow within minutes. You deployed a notebook on Kubeflow, and you can start using it. So I have the place where I leave my data. It's empty, PD2. I'll spin up a terminal, and I'll create a very complicated data set, which will consist of 3 files. But this is a proof of concept for any kind of data processing, right? At this point, I could be going to my data lake and fetching in a few gigabytes of data. This is a local volume, so it doesn't cost to move 100 gigabytes of data from one step to another. It's just there. Another step can come and access the data, instead of having to upload 100 gigabytes of data to S3 and then bring it back, and paying the associated cost in time and money. So this is where I'll be leaving my data, PD2. I'll create, let's say, time is 0132 UTC. I'll create a few files here. Okay. I'll create 3 files because this is the kind of pipeline that I'll run later on. So I have created 3 files. Okay. This is the current state of my notebook. 3 files inside this directory. This is my data set. And now what I'll do is I'll access our software on Mini Kubeflow. We call it Rock. And I'll take a snapshot of this notebook. I'll essentially create a starting point for a pipeline from this notebook. So I log in. This is an empty bucket. We organize data sets in buckets. Okay. I'll bring in a full Jupyter lab, my notebook server. Okay. It auto-completes that this is the one that I'm currently running. And at this point, I'm essentially creating a data commit. So this is why this looks like Git. I'll be committing my seed commit for a pipeline, for a Kubeflow pipeline. Okay. The message will be create 3 files, see the pipeline. Okay. And at this point, this creates an asynchronous task. My notebook is still running that snapshots my notebook. So Rock can be creating multiple point-in-time snapshots of my notebook as I work. And I can then use these snapshots as starting points for pipelines. So this is the task. It's almost done. Everything happens thinly. So if I take another snapshot after 3 seconds, it will take 10 seconds. It's done. Okay. And now my snapshot is done. This is my snapshot. I snapshotted Jupyter user. I snapshotted my data volume and my workspace volume. So I'll keep the URL to the snapshot of my data volume because this is where I'll spin a Kubeflow pipeline from. I copied the URL here. Okay. So now let's see this pipeline. This is another Kubeflow API, pipelines. So this is pipelines. This is the definition of my pipeline in Python. So Kubeflow pipelines defines a Python-based domain-specific language to define your machine learning pipeline. So my pipeline is a Python function. It starts from a Rock URL, the one I just copied, and it says, create a new volume as a clone of this snapshot, this parameter. First step is to mount this volume as /data and concatenate all files into a gzipped file. So first step is gzip everything into full.gz. Then snapshot the results of step 1, so I can retrace what step 1 did seamlessly. Second step is clone this snapshot into volume 2. This happens thinly. If this was a 100 gigabyte volume, I wouldn't have to copy 100 gigabytes. Step 2 is unzip this data, full.gz, and create data/full. That's what gunzip will do. Okay, and use volume 2 as your data, your /data, and take another snapshot. And step 3 is start from a clone of this snapshot and just show me what's in data/full. What you expect to be in /data/full. The concatenation of all 3 files. Okay? So I'll compile this pipeline using the kubeflow pipelines compiler. And compiling the pipeline produces an Argo workflow that we will then submit to kubeflow pipelines. So this is the compiled result, a big YAML file that you don't really have to see. You were seeing nice idiomatic Python, but this is the end result. A big YAML file. Okay? And then I can log into kubeflow pipelines, which is here. And I'll upload a new pipeline, the one I just compiled, example 5. Okay. And do I have to create a new experiment? I don't remember. Let me create a new run. Yes, I do have to create a new experiment, so I'll create a new experiment first. Call it experiment 1. And now I'll create a new run of this pipeline. Okay. Run name is going to be run 5. And the pipeline needs a rock URL to start from. It needs the seed snapshot. So I'll go into rock, get this link, and give it 2 pipelines. Why is this important? Because I can run multiple pipelines in parallel with different parameters from the same snapshot. Why do that? Because I'm an ML data scientist. I want to try out the same model from the same input data with 10 different values for a hyperparameter. So this is how I do it programmatically. I give it the same input data, I give it a different value for each parameter, and they run the same pipeline 10 times. And kubeflow has components that do it automatically. And we are extending these components to work over persistent volumes. So creating the pipeline run, and what this will do is, will essentially show me the pipeline graph being created. So initially, we create a volume. Volumes are this kind of pink-red color, and the volume has been created. So this is a persistent volume on Kubernetes, managed by our software. And now step 1 is running. Okay, let me refresh. Step 1 is still running, okay. Step 1 ran. Snapshot 1 is being created, again as a Kubernetes resource. And because this is all Kubernetes, I can go into Minikubeflow and ask, give me a list of persistent volumes. Okay, this one, this volume is volume 1. It's this run of this pipeline. It's bound and managed by Rock. Okay, give me a list of snapshots. This is the first snapshot. It's been created. Okay. Give me another list of volumes. Now there's a new volume. Why? Because the pipeline is running as we speak. So if I switch to the pipeline's UI and refresh, volume 2 was created, step 2 ran, snapshot 2 is being created, all automatically. Okay, give me a list of snapshots. Snapshot 2 is there, 17 seconds ago. Okay, let me refresh. The UI, however, does not refresh that well, so it will refresh eventually. Snapshot 2 is done. Volume 3 has been created. Step 3 is running. Same thing, another volume will have been created. So we orchestrate the creation of Kubernetes resources from pipelines. This is the easiest way to run full kubeflow pipelines locally. And finally, step 3 is done. I can go into each step and look at input and output. I can look into logs, and the logs of step 3 is the concatenation of the 3 files, because the definition of step 3 was to cat the /data/full file. So this proves that all of the steps ran. But let's say that step 2 had a problem, okay? Step 2 misbehaved. Okay, I'd like to see exactly what its output was, snapshot 2. Maybe I also want to see what its input was, snap 1. So what I'll do is, I'll destroy my notebook. I'll stop this server. Jupyter Hub allows us to run a single notebook here. Running multiple notebooks is not very easy, but the new user interface of 0.5 will show multiple notebooks at once, so I wouldn't have to actually destroy my notebook here. Okay. So what I'll do is, I'll spawn a new notebook, and I'll attach snapshot 1 and snapshot 2 onto this, so I can see what step 2 did. So, I'll be creating a new notebook. Okay. This notebook will be empty, but I'll attach an existing snapshot, which will be step 1. So I go here, I see that Rock has picked up the 2 snapshots, so I'll attach snapshot 1 as a mount point, snapshot 1 on the notebook, and I'll also attach snapshot 2 as another. This is the old Jupyter Lab, and it's dead, of course. Sorry for this, let me close it. And I'll attach snapshot 2. Did I copy it correctly? I don't remember. Let me try it again. I'll attach snapshot 2 here. Okay. So I'm creating a notebook to explore the execution of the pipeline. This is full insight into how the pipeline ran. Okay. Creating the notebook. Again, underneath, I can see that my notebook is being created as a Kubernetes pod. Okay, being created, we'll give it 20, 30 seconds. And within 30 seconds, I'll be able to explore the results of the pipeline that are immutable and reproducible because they are snapshots. Okay, it's running within 28 seconds. This is fast. This is really fast. I'll switch to the user interface. Jupyter Hub is not that fast on the other hand, so I'll refresh. Okay. And what do we have here? We have a notebook, a new notebook, that already has snapshot 1 and snapshot 2 mounted. Snapshot 1 has contents, file 1, file 2, file 3, full.gz. No gunzipped file, because step 2 hasn't run yet. This is the input of step 2. Okay, let's go back. Snapshot 2 has file 1, file 2, file 3, full.gz, and the unzipped file. Why? Because this is after the execution of step 2. So I can have full insight into my pipeline. I can go and see exactly what has changed before and after the execution of step 2. This is super important when you're debugging the pipeline. So this is snapshot 1, and this is snapshot 2, my own local clones. This is it. So what we did is we got kubeflow running locally within 10 minutes. We used kubeflow to spin up our notebook within 30 seconds. We compiled a pipeline that uses local volumes for data exchange we ran this pipeline starting from a snapshot of a notebook, and then when this pipeline misbehaved or broke, we were able to attach a new notebook into clones of snapshots that happened as the pipeline was running for full introspection. That's it. Any questions you may have? Yes, please. Let me bring you the mic.
Thank you for the demo. It was very, very impressive, actually.
Thanks.
Is there a place where we could find documentation about mini KF?
There's not much documentation on mini kubeflow, but there is lots of nicely written documentation for kubeflow itself. So mini kubeflow is just a packaging of kubeflow that's meant to run locally, right? So we have tuned kubeflow so it runs easily and fast on your local laptop. But if you go to...
What about the vagrant command that you shared on your first slide? Are you going to share that somewhere?
I get it. Yeah. We have a... Yes, I can show all of this. So there's a blog entry on the kubeflow blog that describes mini kubeflow. And then it points to our website, which is this. And you can find, the network is slow. You can find both where to get support. We have a channel on kubeflow Slack. And this is the installation guide. Essentially, you need quite some RAM because kubeflow is hefty. And then prerequisites are running Vagrant, VirtualBox, and running these two commands. This is it. So if you go to kubeflow's blog, this is the blog. You should find this, it's up and running, and this should point to whatever you may need.
Got it. Thank you.
Thank you. But I should have a final, presentation slide for this as well. So let me, oh, I missed it, sorry. This is it. Yeah, we're channel #minikf on kubeflow, and if you go to the kubeflow site, you'll find the kubeflow blog and everything. Any other question? Thank you.